siya regarding electrical, nakikiusap ako sa kanya kung maaari ako yung kanyang kuning assistant doon sa kanyang electrician para matutunan ko yung mga paraan ng isang electrician kung paano yung mga ginagawa nila. After po nung sa construction, nakita ko yung ang project namin hindi gaanong tuloy-tuloy at minsan seasonal lang ang trabaho doon. At minsan may project, minsan wala. So, nag-decide ako na maghanap ng iba pang trabaho. So, ang nakita ko, ang trabaho ng isang security guard na pwede kong pasukin. So, nung naging security guard na ako, nakita ko na medyo stable ang kita doon dahil by monthly meron kang kita. Tsaka compared doon sa construction, 3 months lang yung kontrata, minsan wala, minsan meron. Bilang isang security guard, nalaman ko na hindi sapat yung aking kinikita dahil may pamilya na ako.
Bakit ka nag-decide na mag-shift ng career mula sa pagiging security guard sa pagiging electrician?
Nalaman ko na mas malaki yung kinikita ng electrician kumpara sa isang security guard, lalo na kung sa barko ka nagtatrabaho.
Kailan at anong year ka nag-enroll sa Marinas Powerhouse?
Taong 2010, pauwi ako ng bahay, may isang taong nagbigay sa akin ng flyers, nagabot sa akin. So, sa madaling sabihin, pumunta ako doon sa location nila at nag-inquire ako. Nalaman ko na ang isang high school grad na kagaya ko ay pwede palang mag-take ng board exam sa PRC bilang isang registered master electrician. Nalaman ko din na nag-o-offer sila doon ng iba't ibang training gaya ng industrial motor control, building wiring electrician at practical electrical design from residential to commercial hanggang sa high-rise building.
Ano masasabi mo sa serbisyong binigay sa iyo ng Marinas Powerhouse Team Review and Training Center?
So, masasabi ko sa kanilang service, napakaganda ng service sa Powerhouse. Lalo na yung mga teacher doon. Napaka-asikaso nila sa mga reviewees, lalo na sa mga trainees. At tinututukan talaga nila ng gusto yung mga reviewees nila. Nakagaya ko na medyo average lang ang knowledge sa pag-aaral. So, mas nagpo-focus sila at inuunawa din nila yung mga kagaya namin. Dahil alam nila na hindi kami gaanong mahuhusay. So, ang isa pang kagandahan na nakita ko sa Powerhouse, yung kanilang, pag nagturo sila by the heart, at talagang hindi nila kami pinababayaan. Isa pa sa nagustuhan kong serbisyo na ipinoprovide nila ay ang kanilang spoon feeding style sa pagtuturo. At mga review materials, maraming review materials na ipinoprovide sila sa amin na doon maraming lumalabas sa board exam. At ang mga staff nila napaka-friendly, lalo na mga teacher.
Paano naging benepisya sa iyo at sa iyong pamilya ang pag-enroll sa NPHT Review Center?
So, simula nung nag-enroll ako, nabago yung buhay ko dyan sa Marinas Powerhouse. Dahil dyan, nagsimula ang aking pag-asenso sa buhay. At nagamit ko yung mga basic principle na natutunan ko sa Powerhouse. Lalo na yung mga itinuturo sa akin sa pagtutroubleshooting.
Sa ngayon, ano ang eksaktong position mo sa barko?
Sa ngayon, ang aking position ngayon sa barko ay isang electrotechnical officer na yung pinakamataas na rank sa ship electrician sa barko.
May plano ka rin ba mag-upgrade ng iyong skill mula sa pagiging registered master electrician to electrical engineer?
Actually, nakapagtapos na po ako ng BS Electrical Engineering ETIA sa Manuel S. Enverga University. At sa ngayon, ongoing na po ako sa aking pagre-review sa Registered Electrical Engineer Board Exam this coming April 2022. Ako po si Virgilio Daniel Jr., dating security guard. Ngayon, isa ng Electro-Technical Officer. Kung gusto mo tutukan, mag-powerhouse ka na!
Ako'y naririto sa aking trabaho, nag-review sa Powerhouse. Tagumpay ay dala ko, pagpapakumbaba ay natutunan ko. Kahit marami ang tawag sa akin ng amo, ngayon ay alam mo na kung saan dapat pumunta. O pare ko'y huwag tatanga-tanga kung gustong makuha pangarap na lisensya. Kung gusto mo tutukan, mag-powerhouse ka na.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gagaan.
Eliseo Fernando Soriano, o mas kilala sa tawag na Brother Eli. Isang Filipino televangelist at overall servant o lingkod pangkalahatan ng Members Church of God International o MCGI. Matapang,
If you can prove
Você pode provar
that what I am doing is deceit,
que o que eu estou fazendo é engano,
I will have my head cut here.
deixe que corte minha cabeça aqui mesmo.
matalino, at prangka.
Sa relihiyon, ang pinag-uusapan na kaluluwa. At pag yan ay naipahamak mo, wala ka ng paraan para mabawi pag nakuha yan ng demonyo.
Ilan lamang ito sa mga katangian ni Brother Eli na siyang dahilan kung bakit marami ang nahikayat na makinig at manood sa kanyang pangangaral ng salita ng Diyos. Nakilala si Brother Eli bilang host ng the longest running religious program in the Philippines, ang Dating Daan. Naging tanyag siya sa pamamagitan ng kanyang mga Bible expositions na kung saan isinisiwalat niya ang sari-saring panloloko at katiwalian ng mga bulaang pastor at relihiyon.
May mababasa ba kayong talata ang kaligtasan nawawala?
Meron. Pag nabasa ko, talo ka na.
Sige. Agad ang mete. Okay. Ganito.
Eto, Mr. Moderator. Mr. Moderator, eto I am fed up. Ha? Maliligaw ang tao eh. Ito, kahuling-hulihan kong kahilingan sa inyo. Kung mabasa ko bang naiwawala, tatanggapin nyo, talo na. Tapos na ang diskusyon.
Lubos rin na hinangaan si Brother Eli sa pagsagot on the spot ng anumang katanungan sa Biblia sa pamamagitan ng programang Itanong Mo kay Soriano, Biblia ang sasagot.
Naintindihan ko po at maliwanag, salamat po sa Diyos, at naipaliwanag ninyo ng maayos yung kasagutan dahil marami na po akong pastor na natanong tungkol dyan. Wala pong nakasagot.
Salamat sa Diyos. Salamat sa Diyos, kapatid. Ang karangalan ay para sa Diyos na ating kinikilala at pinaglilingkuran.
I'm not offended by what you say, but I respect your words of wisdom from the Bible. I do know that God can only help me for where I've been. And today, I want to become a member of the church. And follow the doctrine according to God's word.
Wala ni isang tanong patungkol sa Biblia ang hindi nasagot ni Brother Eli. At wala ni isang relihiyon at samahan ang nagtangkang gumaya sa estilo niya ng pangangaral ng salita ng Diyos.
Kaya nga may Bible o may Biblia, yan ang kinasusulatan ng mga salita ng Diyos na itinuro ng Panginoong Hesus. Kaya yan isinulat, utos ng Diyos na isulat yan para makarating sa atin.
Pero marami ang hindi nakakaalam na bukod sa pangangaral ng salita ng Diyos, mayroong malaking puso sa pagtulong sa kapwa si Brother Eli. Ang Members Church of God International o MCGI na inaakay ni Brother Eli ang siyang pangunahing katuwang ng UNTV sa pagbibigay ng serbisyo publiko sa ating mga kababayan. Si Brother Eli ang nasa likod ng mga public service ng UNTV na free education, free medical mission, free legal service, libreng sakay, at iba pang programa ng pagtulong sa ating kapwa.
Kahit kami po'y hirap, wala kaming pera, maliit kaming organisasyon, ito ang aming pangako sa Diyos at sa inyong lahat. Magpapatuloy kami sa tulong ng Diyos na sabihin ang aral ng Diyos sa ikaliligtas ng sangkatawan.
Tapat sa kanyang pangako sa Panginoon, February 11, araw ng Huwebes. Ito ang kanyang huling broadcast.
Gracias a Dios por sus esfuerzos, hermanos y hermanas. Somos gratos por su participación. Que Dios lo bendiga a todos.
Papuri sa Diyos, mensahe ng kaligtasan at paggawa ng mabuti at paglalakbay sa matuwid na landas tungo sa kaligtasan pa rin ang kanyang iniwang mga salita. Pinagpahinga man ng Panginoon si Brother Eli, pero magpapatuloy ang mga programa at proyekto na kanyang pinasimulan. isang tunay na kapatid ng lahat, isang mapagmahal na lolo para sa kanyang mga apo, isang mapagkupkup na magulang sa mga ulila, at isang abang lingkod para sa kanyang mga inaakay. Salamat sa Diyos sa buhay mo, Brother Eli Soriano.
Pangako sa iyo, Ama, magtitiis habang buhay. Tulungan.
Paggawa ng mabuti, minamadali rin. Kung paano minamadali mo ang paggawa ng masama nung ikaw ay manggagawa pa ng masama, ngayong nakasumpong ka ng mabuti, huwag kang magpatumpik-tumpik, huwag kang magpa-delay-delay, huwag kang magpabukas-bukas. Pagkakasumpong mo ng mabuti, gawin mo agad.
Mon Hokson, UNTV, News and Rescue. Diyos ang aming sandigan, serbisyo publiko ang aming pinahahalagahan.
Nagtapos na ang 30 kababayan natin na nabiyayaan ng libreng short training course ng Aksyon ni Kuya. Nagbabalik po si Mon Hokson.
Nagtapos na ang first batch ng mga kababayan nating sumailalim sa free training course na ipinagkaloob ng Aksyon ni Kuya Daniel Short Training Courses Program. Sila ang mga nag-aral ng kursong Building Electrician at Wiring Installation. Nagkakahalaga ng mahigit 6,000 piso ang kursong ito, ngunit libre itong ipinagkaloob sa pamamagitan ng Sophia Review Training and Consultancy. Ito ay bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan. Bukod sa libreng training, tutulungan din ng Sophia ang mga nagtapos na makakuha ng lisensya.
Matutulungan din po namin sila in terms of getting their license, PRC license po. Sa field po ng electrician po, ang highest license po na ma-achieve po nila, ito po tinatawag na Registered Master Electrician.
Ang mga lisensyang ito ay maaring magamit ng mga nagsipagtapos upang makapag-apply ng trabaho sa labas ng bansa o di kaya'y sa mga malalaking cruise ship.
Sa barko po, usually po ito po yung requirement. So maganda po ang opportunity rito pag may license sila. Ang mga full-fledged po na master electrician sa barko, ang sweldo po niyan ranging from $5,000 to $6,000 a month.
Ito si Lolo Arsenio, 66 na taong gulang. Sa kanyang katandaan, nais niyang samantalahin ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Kung may pagkakataon na makapagtrabaho, magtatrabaho pa po.
Sa mga darating na buwan ay muling magbibigay ang Sophia ng libreng training sa ating mga kababayan. Mon Hokson, UNTV News Worldwide.
Kay Mundi Hikaya, pagkakaisa
mission and vision, instilling excellence in electrical profession. Having a dynamic professional association, making innovative contribution to our nation. Our members were stronger than chain and bolt, rising to any challenge, involving what's comes and bolts. B-E-R-E-E and R-M-E, connecting industries by the electric circuits. Join us together, IIB. Join us forever, IIB. With power cords cannot be broken. Join us together, IIB. Join us together, IIB. Join us forever, IIB. Synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission quick for reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Join us together, IIB. Join us forever, IIB. With power cords cannot be broken. Join us together, IIB. Join us together, IIB. Join us forever, IIB. Synchronize our hearts to reach greater heights and brighter lights. There's only one institute, no one else can substitute. There's only one
Our speaker mentor for today is a graduate of Bachelor of Science in Electrical Engineering, batch 1996 at University of the East, Caloocan. He earned units in Master of Science in Electrical Engineering, major in Power Systems at University of the Philippines, Diliman, and Master in Construction Management at University of the East, Manila. Former Cadet Engineer, In-Phase Industrial Construct, former Project Engineer, Security Bank Corporation, former Electrical Consultant, Brown Bauhaus Architecture Studio, former Training Consultant, Meralco, former Training Director, PAMAV Training Institute, former CPE Lecturer, IIEE, WESM, PAMAVTech, former Electrical Engineering Regular Faculty Member, UE Caloocan, also former Electrical Engineering Faculty Member Reviewer, Mapua Institute of Technology, Pamantasan ng Lungsod ng Maynila, Adamson University, Rizal Technological University, Technological Institute of the Philippines, Manila and Quezon City Campus, Perpetual University, Las Piñas and Molino, Cavite, Technological University of the Philippines, Taguig Campus, and Pamantasan ng Lungsod ng Valenzuela. He is a registered electrical engineer and a registered master plumber. Ladies and gentlemen, the president of Marinay's Powerhouse Team Review Center, let us all welcome Engineer Reginaldo Kuya Reg Marinay. Our speaker mentor for today.
Hello, sound check. Rinig po ba tayo? Thumbs up lang po, mga kawerpa. Kung rinig tayo maayos. Okay, sige po. Paki-open na po muna yung ating pong mga camera, no? So, we require open camera sa ating pong pre-webinar. So, policy lamang po namin. Pag hindi po kayo nag-open ng camera, you will be removed from our Zoom class, ano? So doon na lang po kayo maaaring manood sa ating pong YouTube Live or Facebook Live, no? But the difference is those who are joining our Zoom free webinar will have a chance to have a free e-certificate, no? So kayo po ang magkakaroon ng chance para makakuha ng libreng e-certificate. Okay? Once again, this free webinar is brought to us by UN Television, your public service channel, and the members of the Church of God International, spearheaded by Brother Eli Soriano and Kuya Daniel Razon, and the Institute of Integrated Electrical Engineers of the Philippines. No? So, hindi po magiging posible itong ating free webinar na linggo-linggo na ibinibigay po namin without the help of our major sponsors, no? So, salamat po sa UNTV, sa MCGI at sa IIEE. Okay po, tayo po'y magpapasimula na. Paki-open na po yung ating mga camera requirement po natin, na open camera. And then kahit one word lang po yung pangalan nyo po sa inyong Zoom name, kahit one word or nickname nyo lang po pwede na, or any decent code name. Huwag nyo na lang pong ilagay yung inyong full name, paki-rename nyo po dahil meron pong ibang mga masasamang tao na kinukuha po ang inyong mga data, nagme-message po sila, especially kung kayo interested na mag-enroll po sa amin. Makakapagbayad kayo sa mga maling tao, yung mga mananamantala, no? Dahil may karanasan na po kami ilang beses na ginagamit po ang pangalan po ng aming review center. Sige po, pakipalitan na po ang ating pangalan, one word lang po, nickname or any code name, pwede rin po, kahit anong code name po na maayos, pwede na po. One word lang po, pwede na. Please do it right now at please see to it na open camera. At kung bukas po yung camera, dapat kitang-kita po yung mukha ninyo. Meron po kasi open camera nga, no? Doon naman nakalagay sa wall, sa ceiling yung camera. I-remove din po namin kayo. Kailangan po makita namin ang inyong mga mukha na nakikinig po kayo ng live. Opo, hanggang 6:00 lamang po ito. Ito po'y libre naman, wala po kaming sisingiling anuman po sa inyo. Ito po'y pinagkakaloob po sa atin ng UN Television at ng IIEE at ng MCGI. Wala po kayong anumang babayaran, ano po, at makakakuha po kayo ng first class quality lecture. No? Hindi po basta-bastang mga lecture po ito, no? Isang bagay na maipagmalaki po namin, makakakuha po kayo ng guaranteed lesson from a licensed engineer, ano po, at and the registered, no, business from our recognized by our national government, ano po. So kami naman po ay hindi naman po colorum na review center, hindi po. Kami po ay nagbabayad ng taxes sa gobyerno. Tayo po ay rehistrado sa Philippine government since 2010. Ano po? Tayo po ay registered by the Philippine government. Kaya yung makukuha nyo pong e-certificate dito ay mapapakinabangan nyo sa pag-a-apply po ninyo ng inyong mga trabaho, Kung kayo po mag-take ng masteral studies, mag-aaral ng ibang courses, ano po, marami pong paggagamitan ng inyong e-certificate po na ito. Marami pong nagkaka-interest dito sa ating e-certificate, ano? Dahil ito po official at legal po itong ating ginagawa po na ito linggo-linggo at hindi naman po tayo i-recognize ng ating national national organization, no? Kung tayo ay colorum lang, ano. So at hindi tayo i-recognize ng also ng isang television network, ang UN Television, ano. Tayo po ay isa sa kanilang mga partner companies, ang UNTV, ano po, isa po sa kinikilalang public service channel ng ating bansa, ano po. Okay po, ready na po ba tayo mga kawerpa? No? Ready na po ba tayo? Sige, thumbs up nga kung ready na tayong makinig mga kawerpa ng ating topic for today. Sige po, at marami pa palang ano. We are sorry po yung ayaw po talagang mag-open ng camera. We will be removing you 5 minutes from now. I-remove na po namin kayo kung ayaw nyo pong talagang mag-open ng camera. At hindi na po namin kayong i-admit kahit po mag-join kayong muli. No? Naka-stop na po. Hindi na po kami mag-a-admit po. No? Pasensya na po. Dito po sa pre-webinar ay may kahigpitan po ang aming policy. Actually, napakadali lang naman po kung susunod lang naman po kayo. Hindi naman po mahirap yung aming requirement. Sige po, antayin po namin ba kayo? Yung mga naka-off cam, ang dami pa po ninyo. I-open na po. I-open na po ang inyong mga camera. Sige po, hindi na po namin pala kayo maantay. Ano? Orasan na lang po namin kayo 5 minutes from now. Kami po magre-remove na po ng ating pong mga participant na naka-off cam. Meron akong nakikita naka-open camera nga pero ano naman yung ceiling lang o yung wall lang nila ang nakikita. Meron kalahati lang ng noo yung nakikita. Mukha lang yung noo lang ang nakikita, no? Kalahating mukha lang. Meron naman madilim masyado. Pakiayos po natin mga kawerpa. Okay. So tayo po ay meron na pong pre-recorded video na mga lecture po namin. Ano? And nag-guaranteed quality lecture po ang inyong makukuha kahit na ito po'y libre lamang. Ay bibigyan namin kayo ng mga sample quality lecture from Marinay's Powerhouse Team Review and Training Center. No? Okay, sige po. Tayo po ay magpapasimula na. Last warning na lang po. Paki-open na po. Paki-ayos na po ang ating pakikinig, yung mga camera. Please make it one word lang po. Wag nyo na pong ilagay ang inyong full name dyan sa Zoom name ninyo. Pakirinig nyo na po ngayon. Pakirinig nyo. Meron pong mga masasamang taong kumukuha ng inyong full name. Most especially yung mga gustong mag-enroll sa amin, yan po mga sinasamantala ng mga ibang tao. We just want to protect you. Meron nga pala tayong pre-registration form. Mag-fill up na po kayo. Your full name, your Gmail account, and your course school. And then mamaya po, bago po tayo mag-dismiss, ay meron pa rin po tayong final na registration. Initial lamang po ito. So please do it right now. Paki-fill up na po. Kailangan po nakapag-fill up kayo sa dalawa, yung initial and final registration form para makakuha tayo ng e-certificate. Okay, mag-start na po tayo. Good afternoon. itong seminar. Okay, sige. So, sir, hindi ba yan bawal? No? Is it allowed by the utility company? No? Like in Manila, no? We have Meralco. Is that allowed by Meralco? No? Yung power factor correction? Well, even Meralco has this capacitor for power factor correction. So, ang mismo Meralco, nagpa-power factor correction din. They are also connecting this capacitor banks in their distribution line. No? Well, number one is for energy saving nga, para makatipid sa kuryente. Ano? So, yun ang dulo niyan eh. No? Yan ang ano niyan eh. That's the climax. No? Yun. That's the climax. That's the most important or the biggest contribution of power factor correction is for energy saving. No? Okay, we'll tackle the theoretical and the practical approach of this topic. I'm giving this seminar in IIE 2 days straight, 8 hours, 8 to 5, 8 to 5. In you, not 2 days, 2 hours. So mas magaling kayo. Okay? You're better than them. The 16 hours will be compressed to 2 hours. I'll just get the nutrients of that seminar. Okay? The most important thing. Okay? So, it is allowed. No? The power factor correction is allowed by the utility company. Okay. So, we have in the utility, in the electric bill, we are paying the generation charge. Let's say this is the electric bill that we have. Let's say at home. Let's start first at home. Okay? So, don't you know that approximately 50% came from the generation charge, not from the power plant? No? This is the generation. Actually, ang laki niya, mga around 45 hanggang 55% yung nakita ko, no? Doon sa aming electric bill. Okay? Yan. And then, alam niyo bang napupunta sa Meralco? Malaki na yung 25% in the utility, no? Maybe around 15 to 25% approximately, no? Goes to distribution, and this is the utility charge. Distribution. No? But when the energy cost increases, we blame the utility company. No, inis tayo sa Meralco. Kaso naman, mayaman na naman si Lopez, di ba? Hindi na pala si Lopez ngayon ang may-ari. Si ano na, MVP na, no? Meralco. And then, around approximately 10 to 15% goes where? NGCP. NGCP. What do you mean by NGCP? Then National, okay, National Grid Corporation of the Philippines. National Grid. I'm sorry, that's wrong spelling. Okay. So, National Grid Corporation of the Philippines. Transmission niya, siya yung dating Transco, di ba? They are the one transmitting the power. Okay? So, napakalaki ng generation charge. No? Malaki yung generation charge na binabayaran natin. Ang napupunta lang sa Meralco, huwag tayo mainis sa utility, no? Do not blame the utility. So, it's only 15 to 25%, no? Goes to the utility company, more on the generation charge. No? Who has a copy of the electric bill here? Can I borrow? I just don't have an electric bill. I just want to show to you that the distribution charge is very low compared to the generation charge. Do you have a copy? May I borrow? Pero naman, no? Kahit na disconnection lang. Okay, wala. Okay. Hindi, sige, okay lang. Hindi, okay lang. Nag-joke na kayo. Oh. Okay. Eto, pansinin mo ito. Okay. Mahal lang ano nito. Ang mahal ng kuryente niya, oh. 237. Adjusted. Okay, generation charge mo. The generation charge is 95%, transmission 16. System loss, 9.88. Tapos mayroong subsidies, may mga deduction. I don't think it's a good, electric bill. You keep this. That is not under normal condition. Okay, so this is the usual. Actually guys, that is the usual. Hindi po bawal ang power factor correction. Hindi po bawal magkabit ng energy saving device. Hindi po bawal yun. Okay. May mga lumalabas lang ng mga binibenta sa SM, sa hardware, no? Nakita nyo yun. Is that true? Okay. Ang masasabi ko, pag pwede siyang totoo, pwede hindi. Okay? Ang tutulong ko kasi sa inyong power factor correction is the one usually being used in the commercial and industrial building. That we will discuss, the principle and application of that. But the one in for residential, although I would say the principle is applicable also, it can be done, but the proper design consideration must be taken, no? With the correct computation of the microfarad, of the capacitor, so many factors that we have to consider at home, no, for residential. Okay? But sa mga commercial and industrial building, it is being applied. And in the distribution line, no, that is being applied. Meralco also has a power factor correction device, no? You see this? That is in the distribution line. And this is in the building. Yung mga ginagamit natin sa building, no? So, commercial and industrial building, no? Yan. Hindi yan yung capacitor na yung sa ECE, yung electronics, yung electrolytic, ha? Hindi yun. Hindi niya kayang mag-correct ng di ba? Ng power factor. So, punta po tayo dito. What is power factor? Power factor is the ratio between the kilowatt and the kVA drawn by any electrical load, where the kilowatt is the actual load power and the kVA is the apparent load power. Okay, question. What power we are getting from the utility company, from Meralco, let's say, in Manila? Okay? Are we getting the kilowatts, the kVA, or the kbar? Dapat doon muna tayo magkasundo. Okay, let us agree this. Okay? Yan. So let's say this is your transformer. What is the rating of your transformer? That is, let's say we have 10 kVA. That is in terms of the kVA now. So, in AC circuit, no? So this is your S, this is P, and this is Q. So this is your theta, right? That one. So, power factor is cosine theta, right? Okay. So this is adjacent over hypotenuse. So we have your P over S. So our P is our kilowatts, let's say, and this is our kVA. Okay? Now, kilowatt over kVA. So ano ba ang power na kinukuha natin from the utility? What power being delivered to us? To be specific, kilowatt, kbar, or the kVA? Actually, we are getting the kVA. This is what we are getting. So, the utility company, or let's say the power plant supplies the kVA. If you are getting the kVA, this is the kVA, the S, right? You're also getting the kilowatt. You're also getting the Q. So, yung dalawa na yung kinukuha natin yun. Okay? Kinukuha natin si P, kinukuha natin si Q. So, dalawa yun. Basically, yung P, bakit natin kinukuha si P? Yung P, siya yung kinukuha ng mga resistance ng mga equipment natin. Lahat ng equipment natin may resistance. No? Yung Q, siya naman yung power na kino-consume, that is being consumed by our inductors and our capacitor. Well, basically, no, most of our building, or I may say all of our building, no, are lacking power factor. Not unless there is some what do you call this, overcompensation, meaning there are a lot of capacitor banks so that your power factor will become leading. So in a normal condition of a certain building that is inductive, no, not unless you put a lot of capacitor banks. Okay, you just take, let's take away all the capacitor bank. All buildings are inductive. That's it. Okay. Now, so this is the theory, cosine theta, P over S, kilowatt over the kVA. It says here that it is a measure of how effectively the current is being converted into useful work. So yung daw kuryente, we can convert that, no, into useful work output. And more particularly, is a good indicator of the effect of the load current on the efficiency of the system. So meaning, the power factor correction, it has a relation with the efficiency of the system. Actually, if the power factor, okay, power factor ranges from 0 to 1, right? There's no power factor greater than 1. There's no power factor that is negative. Okay, that is just ranging from 0 to 1. Now, this is the relation. If the power factor increases, the efficiency also increases. Okay? If the power factor decreases, the efficiency also decreases. Now, how can we say if the efficiency is high or low? Kailan ba natin masasabi na high efficient yung isang system o isang building, o isang equipment? Kailan ba natin masasabi yun? Nakatingin tayo doon sa power quality. Yung quality ng power. Para mas madali sa voltahe. Pag maganda ang voltahe mo, ano ba sinasabing maganda ang voltahe? Yung voltahe, pagka ang voltahe mo 230 volts, sabi ng Energy Regulatory Commission, do not exceed plus or minus 10% of this. So what is the upper limit? That is 1.1 times 230. How much? You can use your calculator. If you have a calculator, the better. How much is this? 253. Is that correct? 253 volts. And the lower limit is 207. Meaning, the fluctuation in the voltage, no, must be ranges from 207 to 253. I'm sorry, we should not include this one. So let's say this will just show the fluctuation of these voltages. Let's say the lower limit, let's say this is the lowest point. That should be 207. And then as high as 253 only. This is being set by the Energy Regulatory Commission. Set to Meralco. They said to Meralco that your fluctuation must only be plus or minus 10%. Okay? So what will be the effect? The system will become low voltage and high voltage. Ano ba ang epekto? What will be the effect pagka low voltage? Well, if there is a low voltage, di ba, pagka low voltage, what can you say about the lighting system? So it's dim, no? So hindi maliwanag, it's not clear. Okay? Yung speed ng motor ko, mabagal. No? Yung aircon mo, hindi masyado malamig, no? Pag mababa ang voltahe. O pag mataas, kabaligtaran, no? Ang bilis ng aircon, ang bilis ng electric fan, yung andar, wala, nag-high voltage kasi yun. Uy, ang lamig nasa white pool, parang turbo ko lang. Uy, ang liwanag maya-maya, puputok na yan. No? Okay, puputok na ngayon yan pagka nag-high voltage yung system, no? Now, nakakatulong ang capacitor sa mga fluctuation na yan. Pag may capacitor ka, ito pa advantage ng capacitor, ha? A capacitor is a voltage regulator, no? If you have a lot of fluctuation, the capacitor will reduce this sudden increase or sudden changes in the value of the voltages. I remember my student, no, sabi ng estudyante ko, third year pa lang siya, "Sir, bakit gano'n sa amin sa probinsya? Ang baba ng voltahe namin." No? Baba doon ng voltahe daw nila sa probinsya. "Sir, 180 lang ang voltahe sa amin." Ang unang tanong ko agad sa kanya, may idea na kasi ako agad eh, "Sir, bakit po gano'n?" O, halimbawa ba, ito ba yung halimbawa, ito ba yung poste ng utility? Let's say that is the pole. It's one. Then you have your transformer here. So, nasaan ba yung bahay nyo dyan? Ito yung poste, ito yun. Nasaan ba yung bahay nyo dyan? Sir, nandito yung bahay namin. Ayun, hayaan naman pala eh. 2 kilometers from the pole. That's why you have a 180 volts. You may say that if you have a high efficiency system, meaning you have a good voltage. Okay? You have a good voltage. Mataas ang voltahe mo. Ibig sabihin, that is near to your nominal voltage. No? Or even a little higher than that. Okay? So, you only have 180 volts here on your house. Tapos ito naman yung ito naman yung poste mo ng Meralco. Ang haba ng service drop mo masyado, right? What is the number one factor kaya bumaba ang voltahe? Voltage drop. That is too long. So you have your voltage drop here. This is your R. This is your I, right? Let's say you have your voltage of the source. Let's say this is your source side, no? And then this is your line side. Just like in the DC circuit, no? This is how we represent this. Let's say there is a battery here, then there is a load here. This is your house. That one. This is your house. So, the voltage of the load here is 1. And then you have your then you have your I. Then you have your voltage of the source. Okay? Do not use Kirchhoff's law. Just use Chap-Chap law. What is Chap-Chap law? This is the Chap-Chap law. The voltage here plus voltage here is equal to the voltage here. So we have here PL plus what? IR. So yung voltahe rito, the voltage here plus voltage here is equal to the source voltage. Okay? So, ganun po yan. Meaning, malaki ang voltahe. There's a big voltage, no? Being eaten. Being eaten. Sabi kasi ng electrician, "Sir, laki ng voltahe kinakain ng wire." Okay? There's a large amount of voltage being eaten by the wire. Okay. Sabi eaten, kinain daw ito. Okay. There's a big voltage, no? Being consumed by the conductor here. No? Okay? That is why 180 volts lang. No? How do we so that we can understand easily. How do we understand voltage drop? Ano ko ba yung isip? Oy, eto. Eto, 100. This is 100 pesos. You give it to your brother, ha? You give the 100 pesos to your brother. But he only received 70 pesos. Muhammad. I give 100, I'm their father. I'm the father. This is the 100. You give this to your brother, huh? He's like your small brother. He only receives 70 pesos. Where is the 30 pesos? Voltage drop. Right? You see, napakinabangan ba niya yun? Did he use the 30 pesos? No. Saan napunta yung 30 pesos? Sa bulsa niya. Kapapan mo. Sa kanya yung 30. You see, that is the voltage drop. Hindi niya napakinabangan nung dapat puntahan. Nawawala yun. Ito, alam mo kung saan napunta sa linya. Siya, sa bulsa. 5-6-0. Yun. 5-6. Okay. Ayan ha. So ito ha. Hindi mag-apply siya. Talaga yung babanggit ko ng 5-6 dito. O ito yan ha. This is now your IR. The IR is the voltage drop. Siya po yung voltage drop. Voltage drop. You see? That is the voltage drop. Okay? Now, take a look. I will multiply this by I. No? I will multiply the equation by I. This one, multiply ko lang siya ng I. So, the equation would be Bs times I will be equal to Bl times I plus I squared R. Right? Right? Right, Len? Right. Okay. This is what we call the power input. That is the input of the utility company to your house. Huh? Okay? Clear? Okay. What is this? PL times I. This is your power output. Okay, very good. There is a plus here, so put here plus. What is this? This is a popular formula of what? Power loss. So meaning, actually the power loss is 1/10 of our system loss. Binabayaran natin. We are paying for the system loss. Okay? So, this one. Okay, let's check the efficiency. What is the efficiency? So, efficiency is equal to power output over power input, right? That's the basic formula of efficiency. So, this is power output over power output plus power losses, right? Because power input is power output plus power losses. Now, this is now your efficiency. Okay? So, we have the voltage drop here. We have the voltage drop. Your power loss will be equal to what? The voltage drop multiplied by I. Isn't it? Okay. Let's take a look at the power loss. That is voltage drop multiplied by I. If I am going to reduce the voltage drop, no? Okay? That is the voltage consumed by the line. Okay? If I will reduce the voltage drop, what can you say about the power loss? That will also decrease also. Diba? Pag pinabaan mo yung voltage drop, bababa din yung power loss. Okay. Pag pinabaan mo yung power loss, kasi bumaba yung voltage drop na, di ba? So, kumonti yung drop mo doon sa linya. So, bababa din yung power loss. Pag bumaba yung power loss, ano mangyayari ngayon sa efficiency? Tataas. So, high efficiency system. Okay? So, ibababa mo yung voltage drop. Yan. So, ito ang ginagawa ng power factor correction. No? One purpose of power factor correction is to reduce the losses. But how the capacitor will reduce the loss? So later I will discuss that into detail. So what I mean is, let us establish this first. Because I've given to you the power factor is directly proportional to the efficiency. Dito muna tayo. No? Pag sinabi natin high efficient, if we say high efficiency, meaning you have a high voltage, a good voltage. If you have a low efficiency, meaning you have a low voltage system. Of course, if your voltage is too low, it's like that one, 180, meaning you have a high voltage drop, right? Okay? I say voltage here, this is the voltage, no, at the load. I'm referring to the voltage at the load here. Okay? If the voltage at the load is higher, meaning you have a good efficiency. Doon mo lang naman nakikita, that's the only gauge that you can say that you have a good power quality. Meaning, if you have a good voltage, pag maganda ang voltahe mo, no? Ibig sabihin na magandang voltahe, kung binigay sa'yo ng Meralco 230 boss, sana ma-utilize mo yung buong 230. Yun ang maganda. Nakuha niyo? Kasi may epekto nga di ba? Pag mababa ang voltahe. Okay, sige. Babalikan pa rin natin yan later, ha? So, introduction lang yan. So, punta tayo dito. The higher the power factor, the more effectively electrical power is being used. Yun na nga, di ba? Pag mataas ang power factor, more effective ang electrical power. Okay? sa pagmataas ng power factor. Eh sir, paano nga nangyari yun? Kailangan pataasin yung power factor para maging efficient. Ayan, isa-isahin natin yan. Ito muna tayo. What is power factor? Power factor is a measure of the degree to which a given load matches that of a pure resistance. No? So, what is the characteristic of a purely resistive load? A purely resistive load has a power factor of 1. And 1 is the unity. That is the maximum. Right? Although I would say the unity power factor, I'll give to you the ideal power factor. This is the ideal power factor based from my experience, 92 to 96%. That is the ideal power factor in the building. Ideal power factor. Sir, why is not 100%? No? So, why is not 100%? If we will make this as a 100%, take a look, huh? So, our P that is equal to your S multiplied by cosine theta, or S that is times power factor. So, if I will make the power factor as 1, so therefore P is equal to S. Meaning, this kVA will become what? Kilowatts. They are just equal. Question, is there a Q? Meron wala. Is there a Q? No more Q. Because S is absolutely equal to P only. When? If the power factor is 1. Now, what is the importance? No? Okay? We need a little Q, just like sugar. We need a little sugar. The doctor would say you drink a wine. That's good for your heart. Need a little alcohol. Right? So, kailangan daw may konting pampasipa daw yun. Red hose. O, ayan. So, we need a little Q because that Q is being consumed by our inductive load. We need that power, a little. Konti lang. Kailangan mo ng konting Q. Para saan? Para ma-utilize mo yung mga inductors mo. Gumana properly yung mga motors mo, no? Yung mga inductive lighting system mo, may ballast yan, no? So, gano'n. Yung mga appliances mo basically are inductive, no? So, kailangan mo yun. Tandaan nyo, ulitin ko lang, ang kinoconsume ng mga resistors natin, yung watts. Ang kinoconsume ng mga natin, coil, no? Are bars. The Q. These are the bars, right? Bars. And these are the watts. And this is our kVA. Or volt ampere. Okay? kVA. That one. Okay? So, we have power factor is 0 if load appears as L or C. No? So, ang power factor daw natin, 0. Kung yung daw load natin, purely L or C. No? If that is pure L and pure C, power factor is 0. For RL, power factor is between 0 and 1 lagging. For RC, power factor is between 0 and 1 leading. I remember when I was faculty member of QE Caloocan, we had an experiment called as a power factor correction. So we have this setup. No? We have this setup. We have a wattmeter here. We have an ammeter. Then we have an inductive load here. We have a voltmeter here at the line side. Let's say VS, then we have the VL. at the load side. Say somewhere here, the BL. And then we have a capacitor here, variable capacitor. So that one. Okay? And we have here a power factor meter. We even have here power factor meter. Yan, power factor meter. So we increase the capacitance, no? In the experiment, this is the result. As we increase the capacitance, see the microfarad. As we increase the microfarad, the power factor also increases. That is the conclusion. No? This is the power factor meter. This is the power factor meter. What is in the middle? 1.0. This is 0 and this is also 0. This is 0 lagging. This is lagging. And this is 0 leading. Yan. Now, this is the pointer. Let's say, pinapit namin ito. Okay? Initially, we don't have a capacitor yet. So there's a certain power factor. Let's say that's too low, 0.3. 0.3 lagging. And then, when we put, no, or when we connect the capacitor, no, across or in parallel with respect to the load, this is your inductive load. No? And then, as we increase now the capacitance, we saw that the power factor meter becomes, the reading becomes 0.4, 0.5, 0.6, no? Even it reaches the 1.0 here, so therefore the system becomes purely resistive. No? It becomes at resonance condition. No? Now, it has also a tendency na maging leading. The system can be a leading power factor. What will be the effect? There is an effect. If the system becomes leading, no? Pag naging leading yan, no? Let's say for leading power factor. For leading power factor, your load voltage, this is your load voltage. Your load voltage, it becomes greater compared to your source voltage. Di ba baliktad? Ano ba ang usual? Di ba sino mas malaki? Si BS o si BL? Siyempre, mas malaki na pa. BS is greater than BL. That's the usual because there's a voltage drop here, right? Okay, but if your system becomes leading, that is what we call the overcompensation. No? Your load voltage becomes greater compared to your source voltage. Okay? So, mas malaki po ang voltahe sa load kumpara doon sa source. And that is what we call what? Remember this, ha? Lumabas na to sa board exam. That is what we call the Ferranti effect. Okay? The load voltage becomes greater than the source voltage. Na? Kuha? So, ganun. Mas malaki yung source voltage mo. What is the usual? Of course, the source greater than the load. No? Because of the voltage drop. But you can increase the voltage of the load as long as you have the capacitor here. If you have the capacitor, you can increase the voltage here. No? Okay? So, that's why there are buildings that they have the capacitor banks. No? What will be the effect? This is not a good phenomenon. That's not a good effect. No? There are capacitors becomes pregnant. Stable capacitor becomes pregnant. There are capacitors that is cylindrical in shape. It becomes like this. Okay? You take a look at this, Muhammad. It becomes pregnant. Something like that one. That one. Tumatabay dito. Kakaroon ng tiyan. No? Kaya para nabubuntis yan, nag-overvoltage yun. No? Dapat i-disconnect mo na siya sa line kasi puputok yun. No? Pwede sumabog po yun. So, ganun. Okay? So, ayan. So, let's continue. So we have most of the loads on electrical distribution system can be categorized into three. So yun na nga. So we have the resistive, we have inductive, then we have the capacitive. Okay? So on modern system, the most common is the inductive load. A typical example includes transformer, fluorescent lighting, and induction motor. If we mean inductive load, so there is a presence of coil, no? Wire wound, no? Coil yan, okay? So, a common characteristic of these loads is that they utilize the winding in order to operate. Ayun. So, they utilize the winding or the coil, no? Yung mga inductive load daw na yun. So, this winding produces an electromagnetic field. No? Yung daw winding nagpo-produce ng electromagnetic field which allows the motor or transformer to function and requires a certain amount of electrical power to maintain the electric field. No? Let's say you have your motor. There is a magnetic flux in your motor, right? There is what we call the revolving magnetic field inside the motor. If there is no Q, there is no cable, there will be no magnetic field. That's the importance of the keyboard. That's why it is not good to have a perfect 1.0 power factor. You should have a little Q. If you make this as 100% perfectly, there's no Q. Later, I'll show you the picture diagram. Let's go first to the theory. This is the theory. Take a look here. So for purely resistive load, okay, so this is the voltage, and this is the current, the red one. That is the current. So if we have here, this one, we have a sine wave. I call this as the starting point. You see this one? This is the starting point. Starting point. Okay? That is the starting point. This one. So this one we call in phase, right? No? I is in phase with V, or P is in phase with I. Okay? That one. Now, going to the positive direction, the starting point of this current is this one. This is the starting point going to the positive direction here. This is the voltage. Which is leading? Is it the current or the voltage here? Sino ang nauuna? Which is the leading? The voltage leading? How did you know? Huh? Okay. Just think of a... The way mas madali. Think of a two runner, or think of a two basketball player. LeBron James and Kobe Bryant. You see the head of LeBron. This is the head of LeBron. He's taller a little, not than Kobe. This is the head of LeBron James. This one, the head. There's the head here, and then there's another head of also. Okay, let's forget this. Okay. So this is the head of Kobe Bryant. Whose head is nearer to the finish line? So they are running, no? This is the finish line always on the left side. The head of LeBron James is nearer. This is the head. This one. That is side view only. Side view. This one. This is the head. So, the head of LeBron is nearer, right? Compared to the head of Kobe. This one. You see? So, sino ang leading? Sino yung leading na una? No? He comes first. If we mean lagging, he comes second. Okay? He comes next. Okay? Hindi na pala pag-English. Ito. Ito yan, ha? Nakita nyo? Malapit na ito, di ba? Kumpara dito, di ba? Okay, reading ngayon yung voltage. How to read this? V leads I by theta. No? So, ganito. Sa mga inductive load natin. So, nauuna yung, voltage. Nahuhuli yung kuryente, no? Let us review a little the AC circuits, no? Okay. AC circuit. Naalala niyo ba yung mga leading, lagging, inductive, capacitive, di ba? Yan, pag-aaralan natin lahat yan. At saka yung application. Magandang topic yung yung power factor correction. It's a very nice topic. Why? Bakit isa yan sa pinaka-paborito kong topic? Kasi power factor correction, that is the application of the theory. No? So we can apply the theory here. Even the calculation, I'll show you later. Okay, I think we are already clear with the resistive load, right? The current is in phase with respect to the voltage. What about now the inductive load? If you have an inductive load, if we mean an inductive load, that is what? A lagging power factor. Lagging power factor. So, we have here, so we have the voltage here. Let's say this is the voltage waveform, and then we have the current waveform. The starting point of the voltage, of course, is here. That is LeBron James, right? And then we have the Kobe, this one. Ito si Kobe. Ito. This is I. So this is the starting point. Okay, just take a look at the starting point. This is the finish line. No? This is mirror. No? This is the finish line. This is the finish line. The starting point of the voltage is mirror to the finish line. The current comes next. So we can say that P leads I by theta. What is the theta? That is the angle between your voltage and your current. Okay? Now, or we may say that I lags B by theta. Na? I lags B by theta. Okay? So, what are the sample of the inductive load? All loads that has coil. Motor, with transformer, with balance, the lighting system, the appliances, most of the loads are inductive. Now, let's go now to the capacity. Capacity load. This is actually a leading power factor. Leading power factor. Let us have this graph. What will be the position of I? This will be your I, let's say. This is your I. Okay? Then this is now your V. This is your V. This again the starting point. And this is now our theta. Remember that the theta, now one definition of the theta, okay, that is the phase difference or the angle between the voltage and current. Okay? So this is the finish line. How to read this? Which is nearer? Kobe or LeBron? Kobe, di ba? Yung current. This is now the current and the voltage. What is this? Current. Current flowing. Walang ka-social. Ano? It should not be the current. It should be this one. It should be the current. Yan. Lagyan mo ba ng H? Current. Just say class, current. Pagkapampangan, kahit wala ng H, no? Di ba? Sino kapampangan dito? Sino yung kapampangan? Pwede ba ako magtanong sa iyo? Ano ba sa kapampangan ng mahabang na tulay? Mahabang pwede. Ganun ba? Ano ka mo? Ano yun? Ayan, okay. Ano ba yung isa? Sisiw pa? Ibon pala pagdating doon sa kabilang tulay. Ano na? Ibahabang tulay doon sa di ba? Okay. Tingnan po ninyo to, ha? Tingnan po ninyo to. Okay? The current leads. Okay? The current. Okay? Do not say the current, ha? The current. The current. Okay. Parang pa call center, di ba? The current, what? Leads the voltage by theta. This is the theory. Or we may say that V, what? Lags I by theta. They're just the same meaning, right? Just the same. Okay? So, if we say I leads, no? I leads, that is leading power factor. Or if we say leading power factor, meaning that is leading current. No? If we say lagging power factor, we say lagging current. So therefore, no, it dictates the nature of the current, not the voltage. If we say lagging power factor, meaning lagging current. No? Leading power factor, meaning leading current. Okay? It talks about the current. Okay? So that is the basic. No? Yan. So, yan yung theory natin. Do you remember in AC circuit? We're just talking only of the theory, huh? Let us strengthen first our theory before we apply. Okay. Let us recall. Yeah. We have 3 triangles in AC circuits, right? What are the 3 triangles? So we have the impedance triangle. So we have the resistance. We have the reactance here. Right? Okay. This is your S. This is your theta. This is your P. And this is your Q. Okay? Right triangle. And again, what is this? This is your admittance. This is your conductance. And this is your susceptance. And this is your theta. The theta here, of course with the resistive, there's no phase difference. This is the voltage, this is the current, right? The theta is only 0, right? Cosine 0 is simply 1, right? Now, take a look. No? Impedance, power, and admittance triangle. If we have 30 degrees here, all of these are 30. 30, 30, and 30. Only means the same. The phase difference between voltage and current, that is also our impedance angle, that is also our power angle, that is also our admittance angle. Ano bang tawag doon? So, iisa lang yun. Pare-parehas lang ang tawag doon. Now, you see, we have here our Z, right? Then the magnitude of Z, no? Then this is angle, bar angle plus minus theta. Then you have your apparent power S, that is magnitude of S is plus minus theta. Then you have your Y. Your Y is magnitude of Y. That is your admittance, reciprocal of impedance, right? Okay. So this is plus minus theta. No? And then you have your I. I will include the I. Magnitude of I is of plus minus theta. That one. This is theta of the current. That's the difference. Remember this, no? Tandaan nyo ito, class. Ha? Pag nakita nyo, pag positive to, if that is positive, this is also positive, and this is also positive. If that is positive, no? The angle is positive, ha? If that is positive, that is capacitive. Ha? It sounds almost the same, right? Halos parehas lang, no? Positive, positive, capacitive. Positive, capacitive. Positive, capacitive. Just the same, right? Positive, capacitive. No? Now, the positive and capacitive, that is wrong. In admittance, if that is positive, that is what? Inductive, right? In the impedance. No? If that is negative, that is capacity. That's the difference. Okay? So, tandaan nyo lang, no? Let us remember, in the admittance, no? Correct? Parent power, positive, capacity. No? In current, positive, capacity. Admittance, positive, capacity. In power, positive, capacity. Did you get that? Did you get that?
Yes.
In positive, capacity. Did you get that?
Yes.
Yes, sir. Yes, sir. Yes, sir. Pag sa admittance, if that is in admittance, if that is in the current, if that is in the apparent power, if positive, capacitive. Did you get that? Yes, sir. You see the yes? You see the yes? Positive is capacitive. Okay? Now, let's continue. Those are the theoretical knowledge that we have to remember. Okay. Now, let's see this figure. So, all inductive load require two kinds of power to function properly. So, we have two kinds, no? So, we have the active or real power. That is the kilowatt. What is the work of this? That is actually performs the work. Just like in the motor, so that your motor will have a torque here. There should be a power developed, right? That is in kilowatts. So that it will have a torque, a force here. And then what will be the function of the reactive power or the key power? Anong trabaho niya? It sustains the electromagnetic field. Okay, so that it will be understood easily. You have your magnetic field in your motor. Let's say north-south, there's magnetic field. Then there is a revolving magnetic field in the motor, right? Okay? Tomorrow, I'll make some discussion about motors, so you attend, no? So, there is a revolving magnetic field in the motor, right? That's why it rotates, that one. There's no physical device that makes this plate rotate, no. That is just purely an electrical, then converted there is a revolving magnetic field. That's why it turns, go around. So it just rotates, right? Okay. That is what we call the revolving magnetic field. Because of that, that's why it is rotating. Okay. Now, ano ang trabaho ni active power? It performs the work. Ano ang trabaho ni reactive power? Sustains the electromagnetic field. Ano ba sa Tagalog yun? Yung active power, para umikot, gumana yung ano mo, it performs the work. Sa motor mo, para umikot siya ng maayos. Yung reactive power naman to sustain the electromagnetic field. The magnetic field must be continuous there. It should always be there so that it will rotate. No? Okay? So, we need first the magnetic field before your rotor rotates. The rotor of your motor rotates. There should be a revolving magnetic field. No? That revolving magnetic field, no? Before you have that, you should have an electromagnetic energy. And that one, that electromagnetic field, there should be an energy first. Energy is work, so that it may rotate. If we don't have this K bar, that will be lost. The rotating magnetic field will be lost. Will your motor rotate? Will your motor rotate? No, it will not rotate because there's no revolving magnetic field. Nakuha niyo ba? Kailangan meron ka munang revolving magnetic field para umikot yung rotor mo. No? Ngayon, umiikot na siya. Di syempre, it can perform now the work, the function. You may put now your blades there, no, your belt, if you have your conveyor. No? Okay? So that's the function of the kilowatt and the K-bar. Now, this is a theoretical explanation for the system with and without capacitor. This is an ideal, I would say, ideal po ito. Let's say we don't have a capacitor. Any building may be represented by a motor. No? Okay? This is a motor. Let's say this is a building. You are getting the color blue. What is color blue? That is your reactive power. What is the color red? Here? That is your active power. So meaning, this is your active and this is your reactive. Meaning, this is your P and this is your Q. Now, you get the P and you are also getting the Q. So therefore, you are getting the S. Isn't it? Tama ba? Kinuha mo kasi yung P, kinuha mo rin yung Q, kinuha mo yung S, automatic. Right? So, kaya kinukuha namin sa Meralco, sa utility, yung KVA. Hindi, sir. Kilowatt lang ang kinukuha natin. Bakit ano? Ang tawag doon sa metro natin, kilowatt hour, di ba? Bakit sir, hindi na lang kilovolt ampere hour? Although merong device na kilovolt ampere hours. There's a meter like that. In the building, in the switchboard, you will find that. You will find that. Even in the building, let's say a high-rise building, it has a power factor meter. So you can monitor your power factor. So, with capacitor, so take a look. This is an idea, I would say. The these two motor are just getting what? The color red. Right? You see, only color red. So, hindi na siya kumukuha ng kulay blue. The capacitor will give you the color blue, which is what? The reactive power. Did you get that? Because the capacitor is a reactive power generator or a reactive current generator. So it can generate reactive power, and it can give you the reactive power you need. No? Yung kailangan mo reactive power, mabibigay sa iyo ng capacitor. Why improve low power factor? Low power factor means poor electrical efficiency. Kailan ba natin masasabi na poor yung electrical efficiency? If the voltage is very low. No? It's very easy. Use the tester. If the voltage is very low, poor electrical efficiency. Okay? The lower the power factor, the higher the apparent power drawn from the distribution network. You see, there's another relation. Let us have this. The lower the power factor, if that is lower, the higher the apparent power, no, drawn from the distribution network. You know this apparent power factor, that is your KVA demand, no, from the utility, from the source. Isn't it that we are calculating the electrical design? Now we are getting the volt ampere of your building, right? Well, if you want to calculate for the size of your transformer, you have to calculate first all the loads, right? That will be the basis on how you are going to size up your transformer and your generator. Right? So it's very important, and you may see that in the load schedules. Okay? You attend the training, huh? We have the training about electrical design. So, manufacturers are often built by their electric utility for having a large inductive load, okay, at their facilities. In Manila, no, I would say the Meralco franchise area, the biggest utility company in the Philippines, Meralco. So they have what we call a maintaining power factor, a standard power factor that they have to maintain according to the Philippine Distribution Code of the Philippines. No? So, we have, if you go higher than, if your power factor, this is your base power factor based on the PTC. Kung mas mataas ang power factor mo sa 85%, no? Higher than 85%, you will have a discount from Meralco. You will have a discount of 0.3% for every percentage point higher than 85%. So later, I'll show you the detail of the computation. If you go lower than 85%, no? Why you have a low power factor? Because you have so many inductive loads. No? If you have so many motors, especially in the industry, kabit ka ng kabit ng mga motor mo. No? So, if you have so many motors, bumabagsak yung power factor, bumababa yung, kung ito unity, bumababa yung power factor, kaya nang dinrawing ko doon kanina. Bumabagsak yan, pagkabit ka ng kabit ng mga inductive load. Now, If you go lower than 85%, you will have here your penalty, or what we call the surcharge. Ilan ba ang surcharge? That is 0.6% for every percentage point lower than 85%. So meaning, bakit ganon, sir? Sir, why is that? Why is that? The discount is only 0.3%. The penalty or the surcharge, of course, this will increase your electric bill if you have your penalty. No? That is an additional charge if you have your penalty. Sir, why is it, if that is a surcharge, that is 0.6? Pag discount naman, yung mababawasan ka ng bayad mo sa kuryente, bakit 0.3 lang? Ba't ganun, sir? Yung negosyo eh. Magagawa natin. No? Business yun. Ba? So, yun ang sagot dyan. So, okay. So, punta tayo dito sa mas mahalagang. Okay. What are the advantages of having or improving the power factor? If we say improving the power factor, we are increasing the power factor near to unity. Not perfectly unity, I would say. Practically. Ideal only is unity. Okay. Advantages of improving. Okay. Well, there is a dash here. So saving money, of course, that's the most important contribution. Okay. High power factor eliminates utility power factor penalties. So there is a penalty here that can be eliminated. Huh? Okay? So high power factor reduces the power or the heating losses of the transformer. And I would say other equipment, no? The heating losses of your transformer, generators, your equipment. If you have a high power factor, no? Hindi siya masyadong mag-iinit, no? Okay? So, pag mababa yung power factor ko, the lower the power factor, it will generate more heat. No? Your equipment will generate more heat for a lower power factor. Okay, let's continue this one. High power factor means high efficiency. Okay, I told you this earlier. High power factor stabilizes voltage level. Again, let's repeat. If you have so many fluctuations, no, put a capacitor. You have a large voltage variations here. Large variation of voltage. If you have a capacitor on the system, there is still variation, but a little, just a little. Konti lang. No? Okay? It becomes more uniform, the voltage. This is what we need, a uniform voltage. We don't need there's always a sudden changes in the voltage or current. We don't need that. That may damage our equipment. No? That is an unregulated voltage. Kailangan po natin ng voltahe constant as much as possible. DC lang constant di ba? DC Ang AC talaga nagpa-fluctuate yan. Okay? Pero kung may capacitor ka, possible pa rin na gumanda yung output voltage mo kumpara dito. This will damage our equipment. Okay. So, high power factor. Okay. Stabilizes voltage level. This is what we call the stabilization of voltage. No? May stabilize na natin yung voltage. Improves machine performance. Well, as I told you earlier, if you supply that electric fan with a low voltage, what will happen? Slow. It will move slowly. No? So, mabagal lang yung ikot niya, yung andar niya. Bakit? Mababa kasi yung voltahe. If you apply a larger voltage, it will move faster. It will rotate faster. Okay? So, improves machine performance. No? Because you apply the rated voltage. No? If the rated voltage is 220 volts, you apply 220 volts, it will function properly. But if that is 220, then the voltage here is 180, it will not work properly. What will happen to your motor is that if you apply a low voltage here, the tendency for your motor, it will throw a large amount of current. A larger current if you supply this a low voltage. Just like in the transformer, right? In the transformer, the lower the voltage, the higher the current. Sir, dito pag mababa-voltahe, mababa rin kuryente. Kay Ohm's law yun. Ang transformer at saka motors, parang ano yan, parehas lang sila. No? Let's say you have in the utility, the pole, which has a larger size of wire. Is it the primary or the secondary? Huh? This is the pole. Then you have a three-phase transformer here. This is the three-phase distribution transformer, and this is our high-tension wire, the primary line. No? So these are our three distribution. And then you will have here, let's say it supplies a certain building, which has a larger cross-sectional area. Is it the secondary here or the primary here? Which has a larger size? The secondary. The voltage here is around 34.5 kilovolts, line to line. No? That is a high voltage. The lower voltage is around 250 or 240 volts. No? So, this is a low voltage, but it has a larger capacity of wire because mas mababa. Diba? So, yung capacity natin, okay? So, mas mataba yung wire mo, no? Pero yung voltahe mo, ano? Mababa. The lower the voltage, the larger the current in the transformer. That principle is carried by the motor also. If you apply a low voltage in your motor, it will draw a large amount of current, a larger. That is the behavior of the motor. So do not allow your motor be supplied by a lower voltage. Huh? Okay, so if your voltage is too small, so you report that in the utility company. They have something to do, maybe there's something to do with their transformer tap changing. That is their immediate response, no? To change the tap changer of the transformer. Do you know the tap changer of the transformer? It's like a watch with one hand, without a minute hand. So, you see this one? There is 1, 2, 3, 4, 5, and then there is an arrow here. If you increase the number from 1 to 2 to 3 to 4 to 5, that will increase also the output voltage. No? Because the principle there is, this is the principle of the tap changing transformer. So we have 1, 2, 3, 4, and 5. So this is 1, 2, 3, 4, 5. If you go higher tap, this is your load. From 1, go to 2. Let's go to 3 or 4 or 5. This is your load. No? From 1 to 2, which has a number, the number of turns increases, right? Okay? Let's say from 1 to 5. The number of turns increases, right? If the number of turns increases, the voltage also increases. That is the relation in the transformer. No? Did you remember the relation in the transformer? The transformation ratio, do you remember this? Any, E-N-I, any, 1, 1, 2, 2, 2, 3. That is 1 and this is also 1, 2, and 2, meaning they are directly proportional. If we be directly proportional, as number of turn increases, the voltage also increases. If that decreases, the other value also decreases. If this is 1 and this is 2. This is 2 and this is 1. 1, 1, 2, 2, 2, 1. If that is 2, 1, 1, 2, meaning they are what? Inversely proportional. As the current increases, your voltage decreases. In the transformer only, it's not in the Ohm's law. It's different in the Ohm's law. In Ohm's law, I is equal to V over R. The higher the voltage, the higher the current. Because the load here is directly connected to the source. This is now your, let's say you have a variable DC source here. So you have your ammeter here. You have your load here. This is your voltage. as you increase the voltage from the source, the current also increases here. The voltage here increases of the load. Because the load is directly connected to the source. Wherein your transformer, your secondary is not connected directly to the source. There is a transformer here. There's transformation going on here. Okay? So, that one. So, okay, another thing is increased system capacity. What do you mean by increased system capacity? Let's say, for example, we have two buildings. For example, we have building A. We have building B. So, increase system capacity. So, this building without capacitor. And this building has a capacitor. Na? Let's say, for example, they have an electric bill of 1 million. Sir, their electric bill is the same as 1 million pesos. What's the advantage? Let's say, two identical buildings. Let's say you have well, identical only the electric bill. You have 1 million pesos, 1 million pesos. No? With capacitor, without a capacitor. If this is your yung dalawang building yan, di ba? So, yung dalawang building na yan, ito dalawang building na to, 1 milyon to, ito 1 milyon din. Oh. Pero sir, bakit? Parehas lang naman ang presyo niya, di ba? Parehas lang ang presyo niya. O ngayon, sir, wala namang advantage eh. Ano naging lamang yan? Naka 1 million ka nga rito, pero mas maraming kargang load to. Kaya, mas marami siyang dala-dalang load. Ayan, di ba? Ayan. Ha? No comment. Okay. So, parehas kang na 1 million na electric bill, pero mas maraming kargang load to. Naintindihan? Naintindihan? O assume, parang ganito, assuming parehas sila ng load, identical, kambal yung dalawang building, kambal. Pero alam niyo ba, wala talaga yung, sa mundo talaga walang perfectly kambal. Diba kaya ginagamit sa pag nag-iimbestiga sa question document, mark. Walang dalawang taong parehas ang mark. Kailangan. Ba? Pero assuming na parehas sila ng load. Ito walang capacitor, ito capacitor. Kung parehas sila ng load, mas mababa ang electric bill nito. Kung ito 1 million, ito 999,999. Mas mababa na piso, ayun ba yun? Pwede na. Hindi. Ang sabi ng mga energy saver manufacturer, pwede ka makatipid as much as 30 to 35% pa. Yan ang sabi. I don't know kung napanood nyo nung araw yung commercial sa TV, yung mga TV shopping lang siya. Yung merong motor dyan. Matagal na yan eh. Siguro 10 years ako pa yung kinumercial. May tayo man, siya naintindihan ko eh. Mga 15 to 30% daw nakakatipid. Hindi naman ako Chinese. Siyempre, meron dito subtitle, diba? Meron siyang motor doon. Pag kinabit yun, bumabagal yung metro. Kita namin, bumabagal. Is it possible? That's possible. Pero there are more engineers who do not believe with that. Ako, pwede ako maniwala doon. Basta tama yung pagkaka-compute, ha? Basta tama yung computation. Pwede ako maniwala doon. Bakit? Kasi na-apply na naman doon sa mga building eh. Di ba may capacitor banks yan? Yun lang naman ang ginamit na principle doon nung in-invento yung gadget. Yun lang ginamit doon na principle. No? Okay. So, okay, let's continue. Okay. So this is the current triangle. As shown here, so this is the motor current. So there are two components of the motor current. There is a magnetizing current. No? This is the magnetizing current. No? This is actually the reactive portion, and this is the active portion. This one. So kumbaga, this is the x-axis and this is the y-axis. No? It's like in the mechanics, right? So in mechanics, so you have your force here. This is your force. This is what? Your f of x, and this is your what? F of y. Okay? So I will explore more this triangle. Okay. Okay, so let us try to imagine we have a load here. May load tayo dito. There is a load here. Your load, no, takes a current from the source. This is your IL. Okay? This is your IL. Load current. No? Now, where is your load current here? Let us draw the phasor diagram. This is the load current. The IL here, this one. Use your calculator later. Ha? This one. Ito siya. So it has two components. This is the x-axis and this is the y-axis. This is the active component, this is the reactive component of the current. Okay? Now, let us put a capacitor in parallel with the load. This one. So this is now your capacitor. Your capacitor will take a leading current, right? Your capacitor is a leading power factor. Leading power factor. So this is your IC. Okay? Can you follow? Okay. Your IC, your IL is on a downward direction because it is lagging. If that is a leading, it is on the upward direction. Okay? So, let's say this is your current IC. That one. That is 90 degree for purely capacitive load. I will project this size. Let's say this is 5 inches. I will project this size. Listen, I will project this size here. Let's say somewhere down the road here. This is your IC, right? Now, this is your total current. From the origin going to this point. This is your IT. And your IT here is this. Your IT means total. Your total current, of course, by Kirchhoff's current law here, that your total current is equal to what? Your load current plus your IC, right? Now, let us assume values. Let us assume. Let's say your IL is 100 ampere. Okay? So, there is a negative angle here. Let's say we have a negative 40 degrees. Plus. So, we have an IC here. Assuming 20 ampere. Any value, So, assumption, this 20 is on, I only assume this. So, this is plus 90. Will you add that? What is the answer? Mode 2 class. Mode 2. Calculator nyo mode 2, then 100 is negative 40 plus 20 angle 90 degrees. What is your total current? Give me the value. How much? 80? 88 point? How much? 48 amperes. Meaning, no, the current reduces, right? From 100 amps, it becomes around approximately 88 amperes. No? It reduces by approximately 12 amperes or more, little more than 11 amperes. Okay? You see? Before you're getting the 100 ampere. Remember, the 100 ampere is the current drawn by your load. And the 20 ampere leading current drawn by your capacitor. And your total current will just be around 88 amps. 0.48. So, paano nangyari yun? How is that? This is 100, this is 20, so this is 120. If you're just doing scalar addition, vector yan, kailangan may angle. Hindi ako maintindihan ng mga technology, no? Pero yung engineering, alam ko, naintindihan ninyo ako. We have to consider the angle. No? Pero alam ko, sa technology, pinag-aaralan yung mga vectors, di ba? Sa physics, meron yan. Graduate kayo ng electrical technology. May calculus nga kayo eh, di ba? Di ba? Ito, physics lang naman yan. So, kung mapapansin nyo, bumaba yung kuryente, no? Ito ngayon yung kinuha mo ngayon sa Meralco. 88. No? Yan na lang. There is an identical triangle. That is what we call the current triangle. Current triangle lang po ito. There is what we call your power triangle. Paano naman yung power triangle? So, ganito po siya. Pares lang ang principle. There is a load flow or power flow, right? So, power flow from the source going to the load. So, let's say we have here your S of the load. S of the load. Now, your capacitor, that is SL here, flowing, correspond to SL. Now, your capacitor will draw Q sub C, and it will deliver Q sub C. No? Kukuha siya ng QC at magbibigay din siya ng QC. Di ba? Okay. Kukuha siya ng QC initially, tapos mag-charge siya, tapos mag-discharge siya doon ng QC. Yun ang gagawin ni capacitor. Nakasunod po ba? Okay. Asan si QC? Ito. Sa Quezon City yun. Ito. Leading kasi siya, di ba? Leading siya. So ito, project mo lang siya dito. So ito na siya. Kung QC, kung ano size no? 3 inches. 3 inches din yun. QC. So, ito na lang ngayon yung kukunin ko sa Meralco. And this is your what? S total. Now, let us discuss this further. Let us go back to SL. If you are getting the SL, what do you call this component? That is your PL, right? PL mo yan. Kung SL yan, ano to Y component niya? Di ba ito yung QL? Isn't it? QL yan. Yung QC mo, ito yung QC mo. Itong CT. So, ito yung QL mo. Tama? Now, ST mo to. Di ba? ST. Kung ST yun, dito triangle na to na yun, di ba? Ano to? Q, T. So, asan yung PT? Ito, physical therapist. Ito. Nakuha niya? Yan yung triangle natin. No? So, let us derive a formula in getting the Q of the capacitor. Ganito tingnan nyo yung QL. Di ba ang QL, saan ba equal sa QL? QC plus QT, isn't it? So, yan. The QC plus QT is equal to QL. Yan Kuhanin natin si QC. That is equal to QL minus QT. Yan. Bayan? Di ba yung power triangle natin? Balikan natin yung basic. S, P, Q. Yan. So, kuhanin mo yung tangent theta. So, katoa. What is the opposite? Q. Opposite, Q. Adjacent. Ano adjacent? P. So, therefore, Q is equal to P tangent theta. QPT 11. QPT. Ayan. Papalitan natin to. QPT. If that is L, this is L, this is also L. Okay? Minus PT, and then tangent theta, T. No? So this is our QC. Or our QC, that is, remember that your PL will just be equal to your PT. So equal po silang dalawa. Ito ay PL din. P of the load to. Sabihin yung kilowatt ng load mo. So this is your PL. Factor out mo yung PL. Tangent theta L minus tangent theta T. So ito ngayon yung general formula natin. Pag-size ng K-bar ng capacitor, so sinasize up yan. See? Yan yung Q ng capacitor. To generalize natin So, the K-bar or Q of the capacitor is equal to P of the load, multiplied by tangent theta ohm minus tangent theta nu. This is the general formula. Pag sinabi natin ohm, yan yung dating power factor. Yan yung dating power factor. Ito siya. Theta L. Yung dating power factor na wala kang pang-capacitor. Naglagay ka na ng capacitor. Ito na ngayon yung theta T. Yung kaprasong angle na yun, yun yung theta T mo. Ayun na yun. Yung maliit na angle na yun, yun yung theta T natin. Tingnan nyo There's a board exam problem like this. Meron daw tayong load 2,000 kilowatt. Ang power factor daw nito ay 80%. We want to increase the power factor. This is the power factor of the load. Power factor to 92% by adding a capacitor here in parallel with the load. Question: what is the K-bar of the capacitor you're going to buy? Bibili ka ng capacitor in terms of the K-bar yan. Okay? So, kuhanin nga po muna natin yung angle niya. So, let's get first our theta L. That is the arc cosine of 0.8. Here, this one, right? This is what? 36.87 degrees. What is your theta T? That is arc cosine of 0.92. What is the angle here? Give me the value. How much? 23.07 degrees. Now, let us get the K-bar of the capacitor, Q of the capacitor. What is the P of the load? This is the P of the load. Okay? So this is 2,000 kilowatts. And then you have tangent theta ohm. The theta ohm, actually, this is your theta ohm. That is your theta M. That is the larger angle, 36.87 degrees. Minus tangent theta nu, minus tangent of 23.07 degrees. Did you get this in your calculator? You can calculate directly. How much class? Ilan? Okay, how much? The Q of the capacitor is dito na lang ha. So we have how much? 600. 48 point 17 kbar. Tama? Yan. So, 648.17 kbar. Isa yan sa rating ng capacitor, no, that we have to buy. No? Before we buy a capacitor, we have to check on the values. Okay? We have to check these values. No? Kasi kung bibili ka ng capacitor, you will buy capacitor, but you have a wrong value. No? You have your Q of C. The one you bought is just like this one. So therefore, the ST here is so just almost the same as your SL. So nothing changes. No? So that will not be beneficial on your part. So hindi ka makakatipid. No? Pagka ganun. Okay? There is a practical vector diagram. This is the practical vector. That is an ideal vector diagram. I'll teach to you the practical vector diagram. I will teach this for the first time, no? In the seminar. No? This is the practical vector diagram. Okay, you'll get power, this one. And make it bigger so that you can see people at the back. This one. This is the SL. That is the kVA taken from the supply. S of the load is the kVA. Now, there is a QC here. This is an ideal capacitor. If that is purely C, diba, our S, that is equal to P plus minus JQ, right? If that is purely Q, your P meaning is 0. Usually, in capacitor, if we mean kVA in capacitor, that is just the same. That is just the same as the K bar. What is K bar? Volt ampere reactive. Okay? So, that is an idea. This is the practical. Tingnan nyo kaya pwedeng pumalpak yung ating mga energy saver. Ito po yan. The real energy saver, it consumes real power. This is, take a look. Say we have that. It's like in a synchronous motor. Let's say this is QC. It's almost the same as the synchronous motor. This is QC. Meaning this, it has a PC here. No? Because a real capacitor bank, it has a certain resistance. It doesn't show here the P of the capacitor, no. That is being disregarded or neglected. Now here, practically, actually we should not neglect this P. No? So, ang pure capacitor, well, theoretically, pure capacitor, walang P. But actually, lahat ng bagay may resistance, may watts yan na consumption. No? So ito ngayon siya. Now, let us project this size here. Let's say, this one is already this one. Okay, we transfer already here. So, that is your Q of the capacitor. Q of the capacitor here. Now, take a look. From this point up to this point, this is your S total, right? Just like that one, your S total here. The S total here is less than the SL here, right? Okay? But there is a possibility that your S total is larger than your SL. You see? There's a possibility. No? Why? Because your real capacitor, it also consumes the watts. Meaning, pag meron tayong watts, pag meron kang watts dyan, pwedeng dumadagdag yan doon sa binabasa ng metro mo na kilowatt hour. Nakukuha niyo, Bas? Pwede yan dumagdag. No? Now, what's important is we reduce this, and we should have maybe a larger, we should have a larger size of capacitor. But we have to be careful. Sana yung malaki na lang ang bilhin natin, if we want the larger size. We are preventing from the overcompensation. Sabi ko sa inyo, yung high voltage, sasabog yung capacitor that may explode for overcompensation. Meaning, the vector diagram will become this one. That one, that is overcompensation. Meaning, nag-correct ka ng power factor, naging ano siya, naging leading. Imbis na gano'n ang itsura, naging ganito. Lumaki masyado ano to. Ito yung Q ng capacitor mo. Okay? So you have to be careful. If you are going to correct the power factor, advisable 92 to 96% based on our experience. It's a good power factor. At 1. Pag ganito kasi 1 pa to, sobra ka na nga sa 1 eh. Pag sinabi unity power factor, if we say unity power factor, up to this point, meaning the angle is 0. But if you go beyond this point, that is already a leading power factor, and that is not good. There will be an overcompensation, and there is a Ferrante effect. The load voltage greater than the source voltage. Nakuha po ba? Nakasunod? So, ganun po ang mangyayari dyan. What do I mean here? No? We have the SL, okay, we have the SL, we have the PL. No? Now, the PC here is an additional load for the supply. Your capacitor itself, it has a real power. It has a watts. No? That is an additional load, taken from the supply. No? the power you need to energize your capacitor. No? Okay? So you better check your system. No? If you increase the value, see to it that is less than 1. Around 0.92 to 0.96. Let's say somewhere here. Let's say somewhere here. And then, from this point up to this point, if you find that this ST, the new ST here, let's say ST prime is lower than this SL, and that's a good compensation. No? Okay, that's a good correction. The kVA here must be less than to your original kVA. This is without capacitor, and this is with capacitor. If we say SL only, that is without capacitor. If we say ST, that is with capacitor. Okay? Okay, so let's discuss this further, some of the slides. Okay, so let's go over this slide. So we have a motor again. So we have magnetizing current. Then we have the real current. No? Actually, this is the x-axis. No? The one I showed to you before. So this is your real current. No? Current for power. Your real current is this current on the x-axis. Okay? Then your magnetizing current is on the y-axis. Alright? So this is your real current. This one. I real. Real, this one. And this is your I reactive. That is your magnetizing current. Magnetizing. Because that is being used for magnetization. So that there will be a rotation on the part of your rotor. So there is a capacitor here. Your motor still needs a magnetizing current. So as shown here, your generator will give you the real current. The capacitor here now will give you the magnetizing current. Because before, you're getting this both from the generator. Now, since you have your capacitor will give you this magnetizing current. As shown here, you have your motor getting the two power, the real and reactive power. But if you have your capacitor, the reactive current will provide, your capacitor will provide the reactive current. Okay? Where's the best location? Saan natin magandang ilagay yung capacitor? Okay, these are some point where we can place your capacitor box. These are your capacitor box. Now, any point that pass the metering, so let's say you have your meter, you can put here, this is your transformer. Usually the service entrance switch gear. You know switch gear or switchboard? That is a board. Is switchboard a board? Yes, that's a board. Right? Okay. So where you can place your meters, your capacitor box, there is a circuit breaker there are relays there are metering there in your switchboard or your switch gear. You can place also your capacitor box on the secondary side of this transformer because previously there is capacitor box on the primary side. And this is the best location, I would say, at the terminals of each load or motor. No? This is the motor, then there is a capacitor here. Okay? There's a capacitor near to the load. No? That's the best location. Because a capacitor is a loss compensator. It will compensate the loss here in the line. So later I will discuss the loss compensation. Okay, this is the power factor analysis. Okay, I will go first here in the power factor. Okay, so we have the customer XYZ. The average kilowatt hour consumption is 1 million kilowatt hour. 1,000 pala, sorry, 1,000. The demand is 2,000 no? kilowatts. So we have the average power factor is 0.7. Remember this is a 70% power factor. And this is a 99% power factor. So let us discuss the 70% power factor first. So this is the basic charge. Let's say the demand charge is 220 pesos per kilowatt. The 220 pesos, that is multiplied by the demand here, 2,000. So that will give us 440,000. And also the same here, in the 99% power factor. Tandaan yan, dalawang column yan, ha? Isang 70% power factor at isang 99% power factor. Dalawa yan. Then we have energy charge, 1.85, let's say. That is multiplied by 1 million. So that is 1.85 million, and this is also 1.85. The total basic charge is 2.29 million here. Just the same. Parehas lang yung 70% at saka 99% power factor. Primary service discount 3%. 3% of this, 2.29 million, is 8,700, and also the same as this one. So special discount, 0%. So actually 0 yun, no? Sa typo error here. 0, 0. Let's go over with the power factor adjustment. Okay? 9%. Where did I get this 9%? Where did it came from? So it came from the 70% minus the 85. You remember, if we have a penalty, how many percent? Penalty, 0.6. Okay, that is 70, right? So we have 85 minus 70%, and that is how much, guys? 15%. And then multiplied by 0.6%. So just forget about the percent here. And that will give us 9. Oh, actually 9%. Let's go back to return the percent. Okay. So we have now the 9% here, right? 9% of what? 2.29 million. That's the 9%. Wherein we have for 99%, we have here negative 4.2. 99 minus 85%. So how much is this? 9 minus 5, 4. 9 minus 8, so we have 14. Then, if we have a 99, that is a discount, right? How much?
0.3.
0.3. We have 0.3 here. Percent. Take away the percent. Go back later. So ito. How much is this? 4.2. There you are. The 4.2%. This is the 4.2 and this is the 4.2. Why is this minus? Because it is a discount. That should be subtracted. Is there a discount being subtracted? Of course not. Okay? So, this one. Are you a policeman? Oh, of course not. My father is a policeman. When he eat, don't pay. But he get change. Okay. No, that's a joke. My father and my brother is a policeman. Okay, so, you see this one? You see this 4.2%. What is the 4.2% of 2.29 million? And that is 96,180. Now, take a look. This is a discount. This is a discount. This portion is a discount. This one. Discount, and this is also discount, right? If we add these two, the total is 164,880. This is the discount to be subtracted here in the 2.29 million. So it comes up to be, the value will be 2,125,120. or approximately 2.12 million. This is 2.12 million. Huh? That is your net basic charge. What about here? This is a discount. But what is this 9% here? Is this a discount? No, it's not a discount. It's a surcharge. It's a penalty. So, okay, let us subtract first the discount here and this surcharge. Okay? 206 minus 68,000. So we have 137,000. Okay, this 137,000, what do you think? Are we going to add this or subtract from the 2.29 million? We add that because that is a penalty. No? 137,400 plus 2.29 million. That gives us approximately 2.43 million. That is what we call the net basic charge. Tingnan nyo ha? 2.427 or approximately round off 2.43 million. Dito 2.12 million. No? Okay? Mababa ang basic charge dito. Mataas ang basic charge dito. Bakit? May penalty. Nakukuha niyo ba? Okay? So ito now, we have the SERA. The SERA is current exchange rate adjustment. So let's say 6%. The 6% of the net basic charge, 2.43 million, is 145,000. The 6% of this, 2.12, is 127. Okay. Then let's have the power purchase adjustment. Let's say 3.28 times the 1 million here, average kilowatt hour. So 3.28. Now you add these three. Net basic charge, SERA, and your PPA. You have now 5 million. I'm sorry, this is a typo error here. So this should be 5.85. That is 5.85 million. This just like this one. This is 5.85 million. And this is 5.5 million. Okay, you subtract the two. That will give us 320,000. And that is your monthly savings. This is just your projected savings, no? That is just your projected total charges, the 5.5. This is actually 5.8. I'm sorry. There's just a typo error here. So this should be 5.85 million. And this is 5.5 million. So the difference is around 300,000. And that is your monthly savings. This is already the existing. This is just the expected. Let's say this is just being done by a contractor of the capacitor bank. Sir, ito matitipid nyo. These are your savings, sir. Approximately, you will save 320,000 a month, sir. Approximately. Annual savings, sir, times 12. That is around 3.8 million. More than 3.8 million a year. How much is the capacitor? How much is that? Sir, the capacitor, I calculated the capacitor is 1,760 kbar. No? Okay? Based on the highest estimate, 1,000 pesos per kbar. Or, let's take out this, 1 bar, 1 peso. No? Ang isang bar, piso. No? Yun ang presyo niya. Kaya nakalculate mo, 1.76 million, 1,760. So therefore, minultiply mo ito ng 1,000, 1.76 million. Itong 1,760. No? Multiply mo lang, dagdagan mo lang siya ng 3 zero. Okay? You just multiply the K-bar here by 1,000. So the answer will be 1.76 million. Okay? What is the payback period? Remember this, any businessman wants to know the ROI. Do you know the ROI? Rate of return. Or what will be the time, how many months, how many years, that my investment will be returned to me. No? Okay? So, Your calculated value is 1.76 million. You divide the 1.76 million by your savings. How much is this? That is 320,000. You divide. If you divide the 1.76 million by 320,000, it will come up to be 5.5 months. Meaning just less than almost half a year only. No? 5.5 months only. Your investment in your capacitor will be returned to you. By what? By savings. No? That is what we call earning through savings. Okay? For how many months will I use your capacitor? Very long, sir. 6 months. 6 months. After the 6 months, it will explode. So, but in 5.5 months, your investment in your capacitor will be returned to you by savings, no? Not the supplier paying the amount, no? I know. Okay? Ibig sabihin, nakatipid ka ng 300,000 sa isang buwan. That is your projected savings. I know a contractor. He gave the consultant, he gave me a calling card. He is an engineer. I want to be like him. He's a very old, senior citizen, more than 60 years old. I saw his calling card. I like his job title. He is energy saving consultant. I like his, he earns a lot, he's rich. His work is, he's not a construction, no, he's not in Meralco, no, he is a contractor of energy saving. Of this, he handles so many buildings. Assuming you handle 5 buildings only a month. He has the 20% of the savings of the building. Just give me 20%, aside from my basic salary in your building, in your company. Let's say your basic salary is 100,000. So if that is 5 buildings, so you have 100, how much? 500,000. Wow, 500,000, okay. I just wish. Oh. So, you have 500,000. That is only your consultancy pay. No? No. Let's say you have your 300,000. What is 20% of 300,000? For example, only 300,000. No, 20%, 6,000 only. No. So 3 times 200, 60,000, right? So the 60,000, they will give to you the 60,000 on top of your basic salary. Because they saved already 300,000 against minus 60,000. 300,000 minus 60,000, more than 240,000. That will be the savings of the company. The company would agree. Okay, sige, patipirin mo lang. Sige, sa'yo na yung 20% ng matitipid namin. Yan ang bayad namin, sir. No? So you see, yun ang trabaho niya. Pinag-aaralan niya kung paano makakatipid ng kuryente yung building. Would you imagine how much is the electric bill of SM Megamall? SM MOA. MOA. Magkano kaya electric bill ng, do you know SM? Mall of Asia? How much is the electric bill? Hindi ako nagkakamali, tama ako. Siguro mga 50 million. Mahal ko. No? Palagay mo na 30 million na lang. O, di ba? Makatipid ka ng ilang percent nun. Tapos sa'yo 20%. O, di ba? Palagay mo na 20% na lang. 30 million, 20%. 30 million. Dami yun. 6 million. Ayun ang natipid. 20% na lang yun. 30% yung natipid. O 30%. Kunin 6 million. O 6 million. Ikunin mo yung 20% ng 6 million. O di sa'yo yun. Kung papayag yung SM. Ha? Okay? So, ayun ang natipid. Okay? Did you get the discussion? Nakukuha po ba? Nasusundan po ba? No? So, anyway, this is quite hard to understand, but at least you have a glimpse, no? You have a little idea on this matter. No? Now, let's go over this next slide. How does Meralco implement discount? So, how does Meralco implement? I just shortcut this slide. This is the summary. Okay. Initially, the power factor is 78.4%. Surcharge, penalty. Ay, pares pala yan. Is this surcharge or discount? Surcharge, because that is lower than the 85%. No? That is 78.4%. That is the power factor. So, as shown here, there is a power factor, there is a penalty here of 11,000 plus 578.7. I just approximate this, around 11,500. This is the 85%. Then you have the 78.4%. Lower than 85%, you have the penalty of 11,500 plus. Now, to maximize, just to see the maximum discount, this is an exaggerated power factor, 100%. There is a discount of 14,400 plus. Although I told you that do not correct your power factor to 100%. No? No. Maybe 98, 99, but still a little. But let's go back to basic again. 92 to 96% would be good. Okay? So, I just saw this in the Electrical Engineering magazine of IIE. This one. So, we have 14,400. That one. Plus. Okay? What is your total savings? What do you think is your savings? This is your discount. Is 14,400 is your savings? You corrected the power factor from 78.4 to 100%. Just to know the maximum discount, the maximum savings. What is your maximum savings? Is it 14,400 only? Sir, that is your discount eh. Yan yung natipid mo. No, that's wrong. Ang talagang natipid mo, what is your maximum savings? Okay. Your maximum savings is 14,400 plus the 11,500. So that is around 25,900 plus. Why, sir? This is your savings. Because you increase the power factor. I remember my student, the power factor. Okay. This is the power factor. Okay. From the 78.4% going to 100. Okay? Okay, 78.4, 78.4, then you touch down the 85%, so you don't have surcharge anymore, right? Because you increase to 85. Now increase, so I want discount, okay. That's why your maximum savings is the sum of the 14,000 and the 11,500. Ibig sabihin, nawalan ka na ng surcharge, nagkaroon ka pa ng discount. No? That's why the two combine the surcharge. No? You will not pay anymore the surcharge because before, the 78.4, you're paying the surcharge, right? You don't have a capacitor. Now, you put a capacitor, 100%. No? You will not pay for the 11.5 anymore. And you get an additional discount pa. So, ibig sabihin, nagsama yung dalawa. Nakuha mo ba? Yun ang ibig sabihin nun. No? Okay, tuloy natin. Well, this is just a table being used by the supplier, contractor. Anyway, ito naman, ginagamit naman, nakakalculate na naman natin. No? Pero, okay din na gamitin yung table na yan. Now to make use of that, there's an example here. For example, we have 100 kilowatt load. We have 100 kilowatt load. Okay? There's a load of 100 kilowatt. The power factor of the load is, this is the original power factor, 65%. We want to increase the power factor to how many percent? 95%. 95%. We want to increase to 95%. Okay? Question, what kbar of capacitor are you going to use? Okay? So your Q of the capacitor, that is equal to the power, the 100 kilowatt, multiplied by this value. What is that value? Initially, we had 65, then corrected to 0.95. So, you'll come up here with a multiplier. How much is this, guys? This is 0.84. So, 0.84. So, therefore, this is what? 84 kbar. That is the size of the capacitor you're going to buy. So, you have your 84 kbar. Right? So this is 84 kbar. This 0.84, actually, this is this one. PL, power of the load, times tangent theta O minus tangent theta U. Do you remember this? The 0.84 is the tangent. Itong 0.84 na to, ito yung the tangent theta O minus tangent theta U. Did you get that? That's why this is a nice table. No? Very useful. Okay? This is the one figure. No? How it look like. No? It looks a cylindrical capacitor, but it is bigger than an electrolytic capacitor in electronics. Just that size. No. That is large. Depends on the manufacturer, the rating. No? That is a modular type wherein you can add the microfarad, the keyboard. No? If you increase the keyboard, the larger the load, no? If you have a larger kilowatts, the larger load, you need a larger keyboard, no? Or microfarad of the capacitor. Okay? You need a larger value. Actually, in Powerhouse, in the RAE review, we have a separate subject about power factor correction. It's more of a computation naman. We compute the microfarad, the keyboard, single phase, 3-phase Y, 3-phase delta. So, doon na namin tinuturo yun sa review. No? So, that one. Yan po ang itsura niya. Yan natin nilalagay. Okay? Pwede mo ilagay sa switchboard, pwede rin sa mga large motors, no? So, doon po natin nilalagay yan. So, ang connection niyan, mga naka-parallel. Naka-parallel lang mga yan. Okay? Ito, modular yan. Meaning, pwede mong dagdagan, pwede mong bawasan yung value ng capacitor natin. Eh, sir, totoo bang babagal lang hanggang ng metro? No? Well, this is the heart of this seminar. This is the last portion that I will discuss to you. Is it true that the meter disc will rotate slower? Will it become slower when you put the capacitor or the energy saver? Is it possible? So this is the discussion. Okay, imagine a large commercial and industrial building where you get the power from Meralco, from the utility. Let's say this is the utility side, no? And then we have a line This is the resistance. And this is your switchboard, your switchgear going to your loads. No? Okay? So, we have here the resistance of the line of your wire. And then this is your meter. That is your meter. No? So again, no? You have your load here. No? Okay, so that you will understand better this discussion. So let's say we have a transformer. You have your transformer here. And then of course there's a secondary line. Okay? I'll just show you the single line. This one, then this will go to your switchboard. This is your switchboard or your switchgear. Right? Can you follow? This one. There's a certain resistance here. There's a distribution line here, underground. This is a large cable or a very long cable. A few meters or a few feet. Let's say 200, 300 feet. The distance between the switchboard, then the switchboard will supply a certain panel board going inside the building, right? And this is your line side from Meralco, let's say. This is an industrial building. Let's say this is probably the substation. Okay? So you have your metering here. Huh? You can have in the substation, you can have your metering here, your primary metering, and then you can have your secondary metering here on the load side. Okay? Now, so initially this will take IL. Okay? So IL yan, ha? Again. So your IL is this one. This is your IL. Let's say your IL is, again, my example earlier is 100 ohms. Well, that is too small. No? Let's say, let's make it as 500 ohms. And then we have here a line current of 500 amperes, no? This one. Okay? Let us put a capacitor here. So this is now your capacitor. Okay? It's your capacitor. Your capacitor, no? Initially, your current IL here, without a capacitor, this is on the line side of Meralco. It will, the current will flow from Meralco side, from the utility going to your load. So if this is 500 amps, all the 500 amps will flow here. Okay? Can you follow? So, yeah. Okay, for easy computation, let's change this because we already have the value, right? Okay? What's important is the principle. Let's say you have the 100 amps. That will flow here. Assuming the resistance of this is 1 ohm. Any value, you can be 0.5 or lower than that, no problem. What's important is the concept or the principle here. So, you have your IN here. Okay? This is your IL. Initially, we have a 100 amps. That's too small. 100 amps. Okay. So you have this. Huh? Okay. Now, we put a capacitor here. Let's put a capacitor. Let's say this is your capacitor. Leading current, that is your IC. This, projected here. Let us project this, let's say 4 inches, project natin dito, IC. This is now your I total. Again, what is your I total? Approximately 88 ohms, right? We compute that earlier. Around 12%, no? Reduction. Okay? Because this is around 20 amps. Try to imagine if we have, okay, kilowatt hour meter and we have a clock ammeter here. You know, clock ammeter, the ammeter, kakak mo lang siya, na? Initially, how much is the reading on the clock ammeter? 100 amps. Somewhere here, let's say you have a clamp ammeter here. Clamp ammeter. 100 amps. Then you put your capacitor here. When you put your capacitor here, is the reading also 100 amps? No. You have already your capacitor? No. Your reading will now become 88 amperes. Now, because you put now a capacitor here. But still, take note, your current here is still 100 amps because this is the rated current of your load. That is the current that you need. It just so happened if this becomes 88. It is because there is a current here which is leading by nature. Nakuha ko ba? Leading kasi ito eh. 20 ampere. Take note ha, may certain angle to na 90 degrees. Ito angle nito, negative 40 degrees. Diba? The power factor. Ayan. So, bababa ngayon yung kuryente na kakainin mo dyan. Okay? So, ganun siya, no? Take a look at the power loss. There is a resistance of the line, so you have the loss here. Take a look. This is a very long distribution line on the building system. This one. So, you have your arc. Let us consider now the power loss. Okay? Again, let's go back to what I teach you before. So, we have efficiency is power output over power output plus power losses or power loss, right? And what is power loss, class? What is power loss? I squared R. Okay? If we decrease the current, the power loss will also decrease. Right? Take a look, ha? Let's talk about the power loss. This is without capacitor. Kung wala pong capacitor yan, ano ang power loss natin? Of course, the 100. Initially, the current flowing here without a capacitor is 100 amps, right? So you have your 100 squared, then multiply by, let's say, assume 1. So how much is this? 10,000, right? 100 squared times 1. What about this with capacitor? What is the new power loss? So you have 88 only, right? Squared times 1. I squared R. Ba? So ilan to? 88 squared. Right, complete na? Ilan yung 88 squared? Ilan? 7,744. Paki-minus mo nga itong dalawa. Let us subtract these two. Ilan? 2,056. Anong ibig sabihin nito? What does it mean? The 2,256. Ito yung nawala. No? Originally, your power loss is 10,000 watts. You put a capacitor, it only becomes 7,744 watts. It reduces by 2,200. Nawala na yun. Okay? The power loss decreases, right? The power loss decreases. If the power loss decreases, because the current decreases, the power loss decreases. As the power loss decreases, your efficiency also, the efficiency increases. Gaganda ang efficient ng system mo. Bakit? Bumaba yung power loss eh. Sir, yung babagal ang metro, yun ang gusto kong malaman. O ito na nga eh. Tingnan mo ha. Ano ba ang binabasa nito? This is a kilowatt hour meter, diba? Kilowatt hour. No? That is, kilowatt is power multiplied by time. Actually, that is energy, right? Kaya energy meter ito eh. Diba? Now, let us forget time for the meantime. No? Let's concentrate on P. What P is being read by our meter? Is that the power input or power output? with respect to your load. The one Meralco is giving you. O anak, ito yung 100 pesos. Is that output o input? That is input. Ito bigay ko sa iyo, sa akin yung 100 galing eh. Nakuha nyo? The 100 pesos came to me. That is my input to you, must be given to him. The 100 becomes 70. Where's the other 10? It's stupid. Okay? So, therefore, this is the power input, no? To the building, to the system, to the customer. Right? That is your available input to your customer. Right? Yan ang binigay sa'yo ng Meralco eh. Input yun. Ang pinabasa ng Metro, input yun. No? Bigay sa'yo ng Meralco. Okay. Ang babasahin ngayon ng Metro mo, mula sa kanya, papunta doon yung consumption lahat ng conductor na ito, papunta doon sa load. Di ba? On the load side. It doesn't care on the line side. Right? Your meter cares starting from itself, the consumption, going to your load. Can you follow? Did you get that? Okay, let's continue. So you are already convinced that this is power input, not the output. Right? Take a look. The energy is power input times time. Okay? Again, energy, that is your kilowatt hour. Power input times time. Now, you decrease the loss, right? What is power output plus the power loss? Isn't it earlier that this is your power input, isn't it? If you decrease the power loss, pag pinababa mo yung power loss, bababa rin yung power input. Tama ba? Tama ba eh? Tama. Pag bumaba yung power loss, bababa yung power input. Ngayon, pababain mo yung power input. Ano mangyayari sa energy? Paababa din yung energy. Pag bumaba yung energy, if you decrease the power input, the energy also decreases. If the energy decreases, your meter will move slower. No? It will decrease its speed. Therefore, energy saving. Did you get that? Mabagal talaga ang dam ng metro. That is the explanation on this principle. Tandaan ninyo, that may be correct. Yung sa residential, and that may be wrong. Kasi in-explain ko sa inyo, nagko-consume din siya ng P. O pwede mas malaki na yung kino-consume niyang current power dahil meron siyang P. Hindi ko sabihin, o pwede mali yun. Kasi, ang mangyayari pala, andito siya, mas malaki pa pala ito, itong ST kesa sa SL. Hindi ka rin nakatipid. Nakakaya? Kasi kung initially, ito yung power at the load, nagkaroon ka pa ng power sa capacitor. So, lumaki pa yung power mo rito. Yung real power mo. No? So, lumaki pa yung real power natin. So, pag lumaki yan, no, ang tendency, lalaki pa yung kVA mo rito. Pag lumaki yung kVA mo, proportional, di ba yung S natin, that is volts times current. O, pag lumaki yung kVA mo, lalaki pa yung kuryente mo. No? So, hindi ka rin nakatipid. Kasi kumuha ka ng capacitor na malaking wattage or resistance. So, better get a capacitor that has a low resistance. Why low resistance? Because a low resistance will consume a lower watts. All the resistive elements consumes the watts. Tandaan natin yun. Ang nagko-consume ng bar, sino? Yung inductor at saka yung capacitor. Yun ang basic nun. Na? Nakuha po ba? So, naiintindihan na po ba ito? Ang power factor is loss compensation. Pinapababa niya yung loss. Actually, hindi niya pinapababa yung consumption nitong load eh. Yun pa rin yun, yung kuryente, yung power dito. Ano pinapababa niya? Yung loss dun sa linya. No? It decreases the loss in the long line. That's why sometimes hindi applicable siya sa mga bahay. Kasi masyadong malapit din yung metro mo doon sa mga panel board mo. Kaya wala din. Masyadong mababa. Kaya hindi rin siya ganun ka-effective. Dapat magaling ang designer ng energy saving na yun para masabing effective siya sa bahay din. Pero ito, kasi na-apply na naman ito sa building, di ba? Siguro yung mga maintenance natin, di ba? Ano, hindi. Meron yan, di ba? Mga capacitor bank. Nasabugan ka na ba niya? Ano, master? Hindi yan. Di pa. Nahawakan mo lang. Naitsa mo. Hindi akin. Ay yung screwdriver, tapos tumama sa gilid mo, ano? May gripo ka ngayon dyan. Okay? So, yun po ang yan, ang explanation dyan. Pinapababa natin, we decrease the loss. Let us decrease the loss. If we decrease the loss, the power input will decrease. Huh? If the power input decreases, the energy also decreases. Okay? Okay, so, well, that's the end of the presentation. Thank you very much. Any question po? Any question? One or two questions? Kung may tanong kayo.
Hello, sound check. Rinig po ba ako, mga ka-aware pa? Thumbs up nga po, kung rinig po tayo. Okay, kita na po yung ating audio at yung video po. Okay, so magandang hapon pong muli sa inyong lahat at salamat po sa ating pakikinig po ng ating topic for today. No? So ilang bagay lang po, mga ka-aware. Okay po, clear na po ba? Karoon lang po tayo ng konting technical problem. Okay, kita na po yung ating video and audio. Okay po, kita na po. Hello, rinig na po. Okay po, ilang bagay lamang po, no? Pakitingnan na lang po natin yung ating PowerPoint presentation, mga ka-aware pa. Okay, so para po sa mga first timer po na nag-attend po ng ating free webinar. So this is the name of our Review and Training Center, MPHT, which means Marinized Powerhouse Team Review and Training Center. Kung gusto mo tutukan, mag-powerhouse ka na. Okay, ito pong ating free webinar na ginaganap po natin every Sunday. So, actually, adjusted lamang po yung time natin for today. So, antabay lamang po sa mga announcements namin sa aming Facebook account kung meron lamang pong konting adjustment po sa oras. Anyway, at least a day before naman, pinopost na po namin yung ating mga free webinar with free e-certificate. Okay, ito po, kasi may mga nagtatanong, what about po, Kuya Reg, yung ating pong free video na sinasabi nyo na mahigit 200 videos na libre. Nasaan na po ba yon yung palibre nyo na yon? Nandiyan dyan po sa ating pong YouTube channel. If you are not yet a subscriber of our YouTube channel, so please do subscribe, like, and share. Actually, around 300 videos na nga po ang pwede nyo pong i-download dyan. Libre po, lahat po yan ay downloadable. Almost 300 videos po yan related to RME, REE, board examination. Okay, so ito po ang ating YouTube channel, mga ka-aware pa, yung ating Reggie Marina YouTube channel. Yan po. I-click nyo lang po yung Reggie Marina and then update lang po from YouTube channel analytics as of September 25, 11 a.m. Meron na po tayong subscribers na more than 12,600 subscribers. And so far, our channel has gotten 503,807 views in a span of 2 years. Na 2 years pa lamang po itong ating YouTube channel at tayo naka-reach na rin po ng mahigit kalahating million views. More than 500,000 views na rin po ang sumisilip, ang nanonood sa ating mga videos. At meron din po kaming private FB group, ito po ang MPHT Review Center. So, pwede po kayo mag-member ng aming private group para updated po kayo sa mga ino-offer po namin. Okay, Meron po kaming early bird promo for our REE review program, no? For REE, it's only 6,000 pesos. For RME naman, 4,000 pesos only. For Master Plumber is only 5,000 pesos. No? Ito po ay online review course via Zoom for April 2023 REE and RME board exam and February 2023 Master Plumber Board Examination. Ito po ay extended promo lang mga kawerpa. Then after this, makakapag-adjust mo kami ng presyo but before September 30 mga kawerpa. So September 30 lamang po yung ganitong amount na kababa na inyong babayaran, ano, as low as 6,000 pesos for REE. RNE naman 4,000 and Master Plumber is only 5,000 pesos. At meron din po kami tinatawag na self-paced review program, no? So, we'll give you a 30% discount, ano, kung kayo po'y mag-a-avail up to September 30. Ito naman po, no, ay fit, no? Sabi kasi nung iba, Kuya Rich, wala akong time masyado mag-review. Very busy ako sa trabaho. So, meron ba kayong program na self-paced, no? Pwede kang mag-review anytime, anywhere. At kahit paulit-ulit kung panoorin yung videos ninyo, pwede ba yon? Meron ba kayong ganung program? Yes. So ito na po yung aming tinatawag na self-paced review program. No? So kahit nasaan ka pa, pwede kang mag-aral. No? Basta meron tayong internet connection. Ano, pwede nyo pong mapanood, no? Yung aming mga review videos, original videos po namin ito, mga kawerpa. No? So kung wala po kayong masyadong time dahil very busy sa trabaho, hindi po kayo makasunod dun sa aming Zoom class, no, as scheduled. So ito ay walang schedule, open schedule to, no. Anytime pwede kang mag-aral, no, ma-access mo yung video natin. Kahit paulit-ulit mo siyang panoorin, okay lamang po 'yan, no. So ito po ang aming pinakamagandang review program so far na nagawa po namin dahil ito po ay depende sa oras na gusto niyo mag-aral, ano. So, kaya ang tawag nga po dito ay self-paced, no? You can go as fast or as slow as you want. Ano? Meron kaming 30% discount promo nito up to September 30 lamang po mga kawerpa. So, we are inviting, no, everyone, no, to attend. Yung mga balak mag-take ng board examination, ano? So, corrected lamang po ito sa April, for April 2023 po ito. Don't worry po. No, kasi nai-offer na po natin ito last batch, no. But for this coming batch for April 2023 RME board exam, no. At meron din po kaming self-paced program for Master Plumber, no, for those who would like to take the February 2023 Master Plumber board examination. At meron din po kaming webinar series with e-certificate and this original video, no, kung hindi po kayo naka-attend ng mga free webinar namin before, ito po yung mga topic na yan, ano. There are 33 topics to choose from, no. At you will have a chance na magkaroon po kayo ng certificate, no, for only 249 pesos per topic. No, so just send us a message, no, kung gusto niyo po, kung kailangan niyo pong papadagdag sa inyong mga credentials, sa resume ninyo. So, mamili lamang po kayo ng mga topic na nandiyan dyan. At po, pwede po kayo magkaroon ng mga certificate, original certificate po na yan. And also, actually, meron din po kaming original certificate na ino-offer kung gusto nyo po yung mismong hard copy, no? Yung mismo pong hard copy with my original sign na maipa-ship po namin sa inyo. Pwede rin po yan. Just send us a message, no? But for our free webinar, ang libre lamang po namin yung e-certificate, yung electronic file po. Nabali kayo na po ang mag-print niyan. But if you want our original certificate with my original sign, no, which is it's a more reliable, no, pagka nag-apply kayo ng trabaho at magagamit no, original sign. So, pwede po, just send us a message kung interested kayo magkaroon ng hard copy po mismo na kami mismo ang mag-print po nito at with my original sign. Ayan. We also have what we call the self-paced special webinar. Ano naman yung self-paced na special webinar? Ito pong mga susunod na babanggitin ko. Ma-access nyo po yung aming mga special webinar, no? Ito po ay wala doon sa ating free webinar, no? We mean special webinar. It's really special, no? Kumbaga, iba po yung mga videos nito, no? At ni-record po namin itong pandemic lang, no? Ito yung mga latest video po namin, no? Per topic is only 990 pesos, but 1 week access po ito, no? Unlike sa free webinar natin, it's only 3 to 4 hours access lang po na maka-attend kayo. Ito naman po ay pwede kayong mag-attend anytime you want, no? Kahit anong oras, no? In a span of 1 week, no? Pwede nyo pong ma-access yung aming video file, no? For 990 pesos per topic. And the first topic is about the building wiring installation. Andiyan na po yung mga course outline. And we also have industrial motor control. No? Gusto niyo po ng mga latest lectures ko po, no? Yan, it's only 990 pesos, no? 1 week access po ito, no? Self-paced po ito. Right? After that, you can get your certificate, ano? E-certificate. And we have the practical electrical design. Ito pong electrical design course po namin ay hinati po namin ito sa 3 module, no? Yung module 1 po namin is residential design. Module 2 is about the commercial and industrial design. And Module 3 is about the high-rise building electrical design. Ano? So, bali 3 module po na hinati namin. So, per module is 990 pesos. No? Just in case you are interested, just send us a message. Ano po? Yan. So, per module is 1 week access po. Self-paced po namin dito ginagawa na po. Ano? Isa-send lamang po namin yung link po sa inyo. Ma-access nyo na po yung file. At pwede nyong panoorin anytime. Kahit ulit-ulitin nyo po. Pwede. And we also have practical electrical estimation course. Ayan. Makakatulong po sa mga gustong maging contractors. No? Ayan. So, given an electrical plan, paano natin mako-quantify at mabibilang yung mga materyales at mapepresyohan natin together with the labor cost and the overall costing. So, nandiyan po ang ating practical electrical estimation course. And we also have the self-paced special webinar, Engineering Math with Calculator Techniques. Ito naman po ay 1 month access, no? 1 buwan po. Actually, 2 months pala. Sorry, 2 months. 2 months access po ng 10 math subject. No? So, ano nangyari doon sa PowerPoint na putol? Okay. Lahat po ng engineering math subjects, ano, ito ay applicable sa lahat ng engineering students, engineering reviewees, at yung ating mga nag-aaral din ng engineering, mga ETF students natin. Ano? So, for only 5,990 pesos, 10 subjects po kasi ito. At 2 months access. Ito po. So, 2 months access po ito. So, with free soft copy of certificate, lecture handouts, meron na rin po yan. At meron din time per subject examinations na ibibigay with solution na po ito, mga kawerta. No? Ito po kasi ay complete mathematics course, no, with calculator techniques. No? Yung mga shortcuts sa calculator din na aming ituturo po sa inyo. We also have a special webinar. Now again, it's only 990 pesos. So, how does an electrician become an electrical engineer in just 1 year through CHED ETF program? No? So, this is an introductory course, no? Kung paano ba magiging electrical engineer isang electrician. Ano? So, totoo ba yun? 1 year lang, pwede na. No? So, i-discuss po namin ang lahat ng details, requirements po with this special webinar. No? So, paano yung mangyayari? 1 year lang, 5 taong kami nag-aral, no, ng BSEE. So, ito na po, bali ang pagkakataon po natin na magkaroon ng mga details, no, kung paano po ito mangyayari, no, yung mga electricians natin na nangangarap, no, maging electrical engineer in just 1 year. No? Ang ating speaker po ay si Engineer Joel Andaya Elige. Ayan, siya po ang ating admin ng BSEE mentoring program, no, ng ETIAP, no. He was also our former student, no. Dati rin po natin siyang reviewee dito sa Powerhouse, no. Graduate din siya ng ETIAP, no. Siya po ang gumawa ng private group na ito, no, na naglalayo na tumulong sa ating mga electricians na gustong maging electrical engineers. Okay, ito po yung school na dapat nyo enrollan, no, so that you can have a 1-year degree program, no. Ito po kasi yung tinatawag ng ating Philippine government na Expanded Tertiary Education Equivalency and Accreditation Program, no. Ito po yung tinatawag na ETIAP program. Okay, isa po sa school na nag-o-offer at pinakamaikli, no. Ang school po na to nag-o-offer ng the shortest diploma, college diploma, no, in 1 year lamang po, no, makaka-graduate ka na ng engineering. Ayan, so sa Manuel S. Enverga University Foundation. Ayan, so diyan po ninyo, diyan po kayo mag-enroll if you are interested, no, to become an electrical engineer in just 1 year. Ayan din po. Ayan din po ang kanilang Facebook account, ang kanilang website, no. So, i-type nyo lang po yung Manuel S. Enverga University Foundation. Yan po yung pangalan ng school. Ito po ay sa Lucena City. Sa Lucena. Ano po? But for now, alam ko may ano po sila, no? Online po sila ngayon, ano? Okay, we also have special webinar sa mga gusto pong maging electro-technical officer, no? Yung mga nagbabalak magbarko, no? Kahit wala pa po kayong experience, ano? Kahit high school graduate lang po, no? Pwede rin po kayong maging isang electro-technical officer, no? So, kung kayo po ay nagbabalak magbarko, no? This special webinar is for you, no? Para guided po kayo sa lahat ng preparations na gagawin po ninyo, no? So this is also a self-paced, no? So 1 week access po ang lecture video na ito, mga kawerpa, no? Yan po ang ating instructor, no? Si Electro-Technical Officer Virgilio Daniel Jr., no? Isa siyang registered master electrician at graduate din po siya ng BSEE ETIAP sa Enverga University. Ayan. Ito naman po ang ating mga original REE books, mga kawerpa, no? So makikita niyo po. So ito pong aming original books, no? Ito ay mga compilations ng mga passboard problem, no, from 90s up to present. Dinagdag na rin po namin dito yung mga latest 2022 board examinations, no, with solution, ha. So kami po mismo yung nag-calculate nito, nag-solve nito. Kaya this is our original, no, review materials, no, and also ayan po yung ating mga customers, no, ilan sa mga bumili po ng ating mga libro. Okay, and we also have our RME review books. Ayan po mga kawerpa, yung ating mga RME review books. Ayan po. Yan sa mga nagtiwalang bumili ng ating mga review materials. And we also have our Master Plumber book. Okay. At ito naman po naganap na contract signing, no? So bilang patunay, no, bilang patunay na tayo po ay kapartner ng ating national organization, no, ang Institute of Integrated Electrical Engineers of the Philippines. Ito po yung mismong television po nila mismo ito noong November 4, 2021. Ano, wala pa pong isang taon ito, mga kawerpa. Naganap po ang contract signing mismo sa head office sa Cubao, Quezon City, no? Head office mismo ng IITE po yan, no? Ang ating national organization is a multi-awarded organization by the PRC. Okay, last year po ang ating presidente ay si Engineer Alan Alvarez, no? Siya po yung ating pumontak po sa atin, no? Nagpahayag po siya ng interest para makipagpirmahan, no? Ito po siya, si Engineer Alvarez. ating 2021 President. At ito po ang inyong lingkod. Ayan po si Kuya Reg. Ayan. Ito po yung naganap na contract signing mga kawerpa. Ayan. At ang ating 2022 nga pala, no, President, no? Siya po si Engineer Feliciano Padua III. Ito po yung nasa kanan naman. Kasi last year, he was the Vice President. Pero ngayon, this year, siya na po ang Presidente. Ayan po, na-post niya po last November lang po ito sa kanyang Facebook account. Ayan po ang kanyang Facebook account. No? Feliciano Flores Padua III. No? Kita mo, hawak po nila, no? Nakita niyo po, hawak nila yung ating REE books, no? Train CPD, Marinized Powerhouse Team, REE Review Materials for IIEE Library, no? So, ang tawag po sa amin ay IIEE UID, no? Universal ID. Kung meron ka po ng Universal ID ng IIEE, mga kawerpa, no? Tulad po nito, so, 200 pesos lamang po ito, no? Kung mag-avail ka po nito mismo sa IIE, magkakaroon ka pa ng additional na 10% discount sa ating mga special webinars, sa ating review program. So, you will have an additional percent discount, no? So, malaki rin po yan. Libo rin po ang halaga ng 10% na yan sa ating review program, no? So, ayan po. Okay, yan naman po yung likod ng ating pong IIEE Universal ID. Ayan. Ito po. Muli ang ating 2021 President. Ito po si Engineer Alvarez at si Engineer Feliciano Padua III. Ito po siya ang ating ayan po. Siya po ang ating 2022 IIEE President. Ayan po. Ayan po siya. Ito po kaming tatlo mga kawerpa. Ayan po. Ang naganap na contract signing. Yes, last November 2021. Ayan. And we are inviting all electrical suppliers, no? Baka meron pong nakikinig po sa atin ngayon ng mga electrical suppliers, no? So, we have this program, no? Promote ko electrical products mo. Let us update our practitioners and students in the latest trend of electrical technology, no? So this is bridging the gap between the academy and industry. Ito po ang aming pinaka-team. We want to bridge the gap, no? By giving lectures, no? Ipe-present po natin ang inyong mga electrical products, no? Dito sa aming pre-webinar na ginaganap, ano? So, hindi po tayo mag-charge sa ating mga participants. No? Libre po natin ibibigay po itong lecture na ito. No? Makipag-ugnayan lamang po kayo sa amin. At the same time, ay naipopromote pa po namin ang inyong mga produkto. No? Let's say you have your transformers, your motors, generators, you have your panel boards, circuit breakers, switchgear, even lighting arrestor, lighting fixtures, no? Any electrical products po na maraming matututunan yung ating mga estudyante at yung ating mga practitioners, no? So, pwede natin i-present ang inyong mga products. At the same time, no, we will give you time also to promote your product, no? Dito po sa MPHT RC family, no? So, ay paano medyo lumalaki na rin po ang ating pamilya, no? So, with our more than 500,000 views sa ating YouTube channel, no? So, pwede po nating ma-promote ang inyong mga produkto na yan, mga kawerpa, no? If you are interested, just email us sa powerhouse_eereview@yahoo.com or send us a private message at our messenger account, the Marinized Powerhouse messenger account. So, dito lamang po kayo magme-message, mga kawerpa, sa Marinized Powerhouse, no? Messenger account, no? At yung mga interested nga pala mag-enroll sa atin, ano, ang ginagawa ko po lately is para mas masabi na legit po, ako po yung nakikipag-video chat, no? So, nakipag-usap po ako, minubuksan ko po yung video para maging legit talaga, no? So, kasi baka ibang tao pa po yung humarap sa inyo dyan dahil may mga ibang tao na ginagamit po yung ating pangalan, ano, sa maling pamamaraan, ano. At ayan, so at least pag nakita niyo po yung aking pagmumukha, no, legit na 'yon, ibig sabihin, ano. So at yung aming account, no, yung Facebook account namin, ano, ayan. At yung amin naman pong cellphone number naman na official ay nandoon naman sa aming Facebook account, no? Aming cellphone number. Okay? So, ayan po. And we also would like to thank our industry partner, the RBN Engineering and Development. No? It's an electrical contractor at ang ABL System Engineering Design Services. It's an electrical design firm, no? Yung ABL Engineering, no? By its PE, no? Engineer Arnold Dovino. Ayan. So, sila rin po ang ating katulong sa pagbibigay ng mga libreng webinar po para sa inyong lahat, no? Okay, so sa ating po, tayo po yung magpapaalam muna, partner, no? Sa ating YouTube live at sa ating Facebook live. Maraming salamat po. Antabay lang po yung mga nasa Zoom class po natin. Salamat po sa inyo mga kawerpa. See you again next week, no? God bless. Maraming salamat po. Thanks be to God.